Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi and welcome to this Azure Virtual Training Day where we're looking at implementing hybrid cloud. So this virtual training day is made up of 5 sessions that will occur across 2 separate sort of partitions. In the first partition, we're going to do 3 sessions. And the first of those sessions, we're going to look at an overview of what hybrid cloud is so that you can understand all of the high-level components that connect your on-premises resources to Azure. In the second session, we're going to look at implementing hybrid identity and hybrid networking. So all of the components that allow you to connect this to that and all of the components that allow you to have a consistent identity experience. The final part of this first partition is going to be about hybrid cloud compute workloads and how you manage those. Anyway, look, I hope you really enjoy this virtual training day. And now we're going to move into the first session. Now, the first session, what's that about? Well, as I said, and let me give you a bit more context about that. This first session is about how we look at all of the components at a high level that exist within a hybrid cloud infrastructure. So let's get into the material. This session is an overview of hybrid cloud. So the aim is to give you that general overview so that you have a map of the territory ahead of the things that we're going to cover in the next couple of modules. This is unashamedly an introductory level module. So if you're looking for a bit more meat, you're going to get those in the other modules in this session. And in this session, we're going to be bringing up a bunch of examples. And the examples are sort of conceptual examples that allow you to understand how you can use hybrid technologies to solve problems that your organisation has. Because one way to think about hybrid cloud is that hybrid cloud is an extension or an upgrade or a set of improvements that you can make to your on-premises infrastructure. Hybrid cloud's not about replacing what you've got with the cloud. It's about integrating what you've got in the cloud. All of the technologies that we're going to talk about in these examples are going to be fleshed out in far more detail by the later modules in the learning path, or of course you can go into docs.microsoft.com or the appropriate MS Learn modules. The idea behind these narrative examples is to provide you with sort of a bit of a break between talking specifically about concepts, but also to allow you to think about these technologies in a slightly different way. Rather than me just presenting on a technology and then giving you an example of the technology, the idea behind this presentation format is to give you an example of a problem and then how we can solve it with a specific technology. Because once you understand a problem that something solves, you understand the technology a lot better, rather than describing the technology, for example, going all the way into describing how a wrench works before talking about the need to tighten some nuts. Okay, all sessions in this learning path are going to use the Tailwind Traders fictional company. Now, you don't need to really know a lot about Tailwind Traders other than they've got a central office. And they've got branch offices, and those branch offices are spread across cities in multiple countries. Now, even though they're spread across multiple countries, they've got a single Active Directory domain services forest. and branch offices are connected to one another using a single hub and spoke topology, with the head office being the hub and VPNs and direct connections coming in from the spokes. Now, Tailwind Traders has been around a while. That means that they've got a substantial amount of resources on-prem, and they're not going to start, especially in these times, splurging cash on completely transitioning to the cloud. They're going to continue to require their on-prem Active Directory for the foreseeable future, and on-prem Active Directory should be the primary source of identity. What they're going to do, though, is that they're going to adopt technologies in the cloud where it makes sense, and they want to be able to connect to those technologies in the cloud in a hybrid fashion. So let's talk about the Tailwind Traders hybrid strategy. They're a multinational. They've got, let's say that they're in Australia and New Zealand and Singapore. They've got an on-premises deployment. However, that on-premises deployment's been around for a while. They've got aging infrastructure, and their infrastructure is running close to capacity. They've got space in a colo facility. They don't want to hire more racks. They've got servers that they've had since 2008 or 2012, and they don't want to go and buy new equipment if they don't have to. However, they're slowly and steadily growing. Not at a rapid rate, just in a nice, slow, steady rate. And rather than buy those extra racks, rather than expand their on-prem capacity, they're sitting there thinking, you know what we might do is we might extend things into the cloud so that the cloud becomes our buffer. And if we know that we need something, well, then maybe we bring it on-prem or maybe we keep it in the cloud. We're going to see how this thing works. So they want to enhance that on-premises deployment with appropriate cloud technologies. What they don't want to do is they don't want to pick up an existing server that's working perfectly well and just shift it to the cloud because a consultant told them that that's an awesome thing to do. Sometimes it is an awesome thing to do, but sometimes that on-prem server that works really well should be kept on-prem. But new servers, well, instead of going out and buying hardware for them, maybe you go and run those in the cloud. So Tailwind Traders is really, and this is the core of this idea of hybrid, looking to achieve an optimal balance between their workloads, existing workloads hosted on-prem, and new workloads hosted in the clouds, or where it makes sense, moving a workload from on-prem to the cloud. In this session, we're going to cover the following topics. We're going to come up with a definition of hybrid cloud. And everybody's kind of got their own one, but we'll work with a functional definition here. We'll talk about a variety of hybrid cloud architectures. There are many, many, many ways to do hybrid cloud. There's certain ones that are reliable. There's certain ones that we know that work, and they've been codified as architectures. We'll talk about the elements that make up most hybrid clouds. We'll talk about the tools that you can use to manage and govern your hybrid cloud. We'll talk about some of the things that you need to think about if you've got data in the hybrid cloud. And we'll also hit some challenges and really reinforce that hybrid cloud or any adoption of technology isn't all upsides. There's other things that you need to consider. There's things that you need to be aware of. And sometimes in these sort of sessions that they can only give you the good bits and they won't say, well, here's some of the drawbacks as well. You've got to understand the balance that you're striving for. So, what is a hybrid cloud? For the perspective of Microsoft Azure, a hybrid cloud is a stable state, not a transitional state, but a stable state where an organisation will host some workloads on-prem and other workloads in Azure. So this is an important statement. We're not talking about hybrid as a transitional state. We're not saying that hybrid is the road that you're on between on-prem and the cloud. We're actually saying that hybrid cloud is a destination where you're getting the best of both worlds. In a hybrid cloud environment, you've got resources on-prem, and those resources on-prem are able to communicate securely and seamlessly with resources in the Azure cloud. So what that means is that the communication between the elements of this cloud, be it on-prem or be it in an Azure data center, have secure communication. It's not something where someone can easily go and intercept that communication or interrupt it or modify it. In a hybrid cloud, you have a consistent identity infrastructure for authentication and authorization. Now, what that means is it means that you're not using a separate set of accounts to authenticate against cloud resources compared to the accounts that you use to authenticate on-prem. Now, it might be that you have a single identity provider. Most likely, given that this is Microsoft, it's going to be something like Active Directory. But what you're not doing is you're not doing what used to happen at a place I worked in the 90s, where each system that the staff interacted with required a separate set of login credentials. And people had to keep notebooks around to look up what the credentials were for a particular system that they were interacting with. If they were enrolling students, they looked at one thing. If they were doing faculty finances, they were doing another one. In a hybrid cloud, you've got a consistent identity. If you need to authenticate against a web app on-prem, you use that identity. You use the same identity to authenticate against a database running in the cloud. Now, the other thing about a good hybrid cloud is that you've got a consistent set of tools that allow you to manage on-prem and cloud workloads and infrastructure. What does this mean? It means that, again, you don't need to pull out a different toolbox if your stuff's on-prem compared to the toolbox you pull out if your stuff's in the cloud. In the best of all worlds, you're using a single tool to manage workloads on-prem or in the cloud. And in the best of all worlds, you don't really need to know if the workload's on-prem or in the cloud. You're just using the tool to manage it wherever it is. Now, the other thing and the final thing in this particular definition of hybrid cloud, and there's other definitions out there. This isn't certainly something formalised by something like NIST. It's that you have a consistent set of technologies used to secure your on-prem and cloud resources. So just as I said, you don't have a different toolbox for managing on-prem as opposed to managing the cloud. You have a single toolbox in terms of your security tools to manage or to secure on-premises and cloud resources, that you can assess the security of your resources, or you can be alerted to infiltration or security misconfigurations using a single set of tools for on-prem and cloud, rather than, again, having to go, well, I need to know if there's a security alert. I'll look at my cloud security alerts and they're over in this box, and I'll look at my on-prem security alerts and they're over in that box. Okay, so now that we've got that definition out of the way, let's look at one of Tailwind Traders' challenges. So they've currently got Windows Server virtual machine workloads that are dependent on Active Directory domain services, which is fairly common. A lot of people obviously have AD and they've got Windows Server VMs. Now, in this particular case, these workloads are dependent on an Active Directory schema customization, and that this application or these workloads are present at various branch offices. Now, these workloads are running alongside virtualized DCs on aging virtualization host hardware. I mean, maybe they took Windows Server 2012 R2, put Hyper-V on it, and then put a bunch of VMs there. And this hardware is getting near end of life, working for a certain amount of time before you'll start seeing an increasing number of failures. The reality is, for Tailwind Traders, the workers in these particular branch offices still require access to these workloads. One of the things that Tailwind Traders has looked at is they thought, well, could we migrate or centralise this? And because Tailwind Traders is a multinational organisation, it doesn't make sense to move these workloads too far from where they're already currently located. Okay, so with those challenges in mind, what kind of solutions could we use hybrid with? Well, one of the things that we could do is we could connect each Tailwind Traders branch office to Azure using a VPN or ExpressRoute. A VPN, virtual private network, is an encrypted connection that runs over the internet. ExpressRoute is a high-speed fibre optic connection that runs straight over a private link that doesn't cross the internet into an Azure data center. So what Tailwind Traders could do is they could deploy brand new Windows Server IaaS VMs, that's a virtual machine that runs in Azure, and configure those VMs as domain controllers, and then configure a new Active Directory site in the existing domain to represent that Azure data center. They could move those VM workloads from the aging virtual machine hosts out at the branch offices into the Azure virtual networks that have got the IaaS VM domain controllers. So basically what they're doing is they're replicating that infrastructure that exists on-prem at the branch offices and moves it into the cloud. And that's a case where, okay, the aging virtualization infrastructure doesn't need to be replaced, and the virtual machines are still able to interact with that custom schema. Because there's certain situations where people move stuff into the cloud, and unless they replicate those schema changes, they're not going to work with those VM workloads. So let's look at an example hybrid deployment. In this particular image, you can see that we've got the on-prem network, and we've got a connection to a gateway subnet, and on the on-prem network, we've got our Active Directory domain controllers, and that our on-prem network does have a perimeter network that's got a public IP address. Now, the gateway subnet runs through to the application subnet. There's a separate subnet on that virtual network that hosts the domain controllers. And those domain controllers are able to replicate and be part of the same domain or the same forest, depending on how you configure it, as the domain controllers on-prem. And if they're part of the same forest, they can have exactly the same custom schema extensions, just replicate as part of that forest. There's no need to come up with a separate infrastructure and then modify the structure of the schema in the cloud. Or at some point you could do that. It just depends. But that's one particular hybrid scenario or hybrid solution for that specific set of circumstances. And as we'll look at in future sessions, if, for example, those workloads did have an Active Directory dependency, but they didn't require the custom schema extensions, well then maybe another option would be appropriate. Maybe we could domain join them to an Azure Active Directory domain services domain, which allows you to virtualize domain controller as a service. And we'll get into that sort of situation in the next session in this virtual training day. So let's talk about hybrid cloud architectures. Microsoft publishes and updates hybrid cloud architectures on docs.microsoft.com. To understand what a hybrid cloud architecture is, it's sort of a best practice solution for a specific problem that you might have. It gives you a reference way of solving the problem. It doesn't mean that's the only way of solving the problem, but what it does is it gives you a look. If you've got this particular scenario, this is how you can take an off-the-shelf solution and start to tinker with it by yourself. And in the slide is a screenshot of the hybrid cloud architectures page. Inclusive in the existing hybrid cloud architectures, and more are being added all the time, we have architectures such as how to manage configurations for Azure Arc-enabled servers, how to use Azure automation in a hybrid cloud environment, how you can use Azure file shares in a hybrid cloud environment, how to use Azure automation update management to manage your updates, how to use hybrid file services so that you've got file servers on-prem and in the cloud, how to use hybrid security monitoring with Azure Security Center and Azure Sentinel, how you can run containers in a hybrid environment, how you can extend on-premises Active Directory Federation services through to Azure, how you can manage hybrid cloud workloads using Windows Admin Center, that is, manage your workloads on-prem and in the cloud, how you can implement a hub-spoke network topology with the cloud, given your existing network infrastructure, how you can use Azure Arc hybrid management and deployment for your Kubernetes clusters, how you can connect an on-prem network to Azure, that one's obviously a fairly basic and straightforward one, how you can scale your on-prem workloads into the cloud, how you can integrate your on-premises AD domains with Azure Active Directory, and how you can configure Active Directory domain services resource forests, that is, where they host resources, not accounts, in Azure. Okay, so let's get on to the next challenge. And in this challenge, when we're thinking about how hybrid works, we're looking at web applications. So Tailwind Traders has branch office perimeter networks that host web applications in multiple countries that they wish to decommission. Now, I'm sure you're aware of this, but if you've kind of forgotten how this works, basically a lot of organisations have got perimeter networks, sometimes called DMZs, that sit there and they host web applications, and people connect over the internet to those web applications, and the web applications do something related to the business. Now, perimeter networks are expensive to maintain, not just because of the equipment, but the moment you basically in some way allow inbound traffic to your network, even if it's sitting on a perimeter network, you've got a whole lot of questions and you've got a whole lot of decisions that you need to make about security. So one of the other things that Tailwind Traders knows is that several weeks a year, when they run an online retail campaign, those applications can simply get overwhelmed with traffic and fail. And this annoys customers, it annoys management, and it of course annoys IT because they get blamed for it all. So one of the things that Tailwind Traders wants to do is they want to make sure that during those periods where they're going to be hit by massive traffic, they can cope with it. But what they don't want to do is they don't want to go and put in place massive infrastructure to deal with something that's only a problem less than 5% of the year. The other thing that they want to do is they want to put in OWASP filtering and distributed denial of service protection for their web apps. And they don't want to be sitting there managing complex perimeter network firewall systems. One of the things that they've learned is that occasionally people would run denial of service attacks against their applications during one of these retail campaigns, which meant that the websites went down faster. So what can they do about that? Well, solutions exist within hybrid. What Tailwind Traders can do is that they can move all of those perimeter network web applications and host them on networks in Azure. In fact, Azure and the cloud is really well suited to the migration of perimeter network applications. Instead of hosting the perimeter network adjacent to your on-premises network, what you do is you move your perimeter network up to the cloud and you allow the cloud to handle all of that. And then you've got a VPN or an express route connection up to that network itself. Remember, if you've put it in a perimeter network, it is an externally facing application. So it's really suited to running in the cloud. Now, you can protect applications from attacks that are on the OWASP top 10 list. So what's the OWASP? It's basically a list of the top most common types of attacks that are run against web applications. And you can also protect against distributed denial of services, basically by putting in place Azure technologies such as distributed denial of service protection and web application firewall. If you go and put these web apps in the cloud is purpose-built to allow you to scale up and down as your traffic fluctuates. You can configure a web app so that if it starts to hit a certain number of requests, bang, it adds more instances to that, or it adds more powerful instances to that so that it handles the traffic. And as the traffic disappears, the web app shrinks itself back down so that it's running in the most efficient and, more importantly, the cheapest way possible. So let's talk about the elements of a hybrid cloud solution. Your hybrid cloud solution needs to have management, identity, networking, security, and fabric when you think about it. So from the management perspective, make sure you've got a consistent set of management tools to manage on-prem and cloud workloads. Now, when we're talking about Windows Server heterogeneous networks, that is, that you might have some Linux there, you'll have already figured out a way to manage your Windows Server and your Linux workloads on-prem. What you don't want to have to do is pick up a third set of tools to manage your workloads in the cloud. What you want to do is you want to use the same set of tools to manage your workloads on-prem and in the cloud. So with Windows Server, you can use Windows Admin Center to actually manage on-prem and Azure workloads. You can use Azure Arc to manage the configuration of all your Windows servers and your Linux servers on-prem or in the cloud. For identity, you want to use a single identity provider for authentication and authorization. Now, that might be straightforward, bog standard Active Directory that you run on-prem, or you might move everything to Azure Active Directory. If you've got Office 365, you're already using Azure Active Directory because what's happening is that you've already got identity synchronization where people are logging in to Office 365 using their on-prem accounts that are replicated up from your on-prem domain controllers. Your networking needs to be secure and reliable. You need to have a way of making sure that you can connect your on-prem network to Azure. What you don't want to do is you don't want to have everything on your on-prem network initiating its own independent connection through to the cloud. You want to set up a secure pipe, be that an express route connection or a VPN connection to allow that communication to occur. And it needs to be reliable. So you need something that's actually supported by the cloud provider. You need to have a single set of tools to monitor and respond to suspicious activity. Now, luckily, you've got Azure Security Center and Azure Sentinel, and these can be used to ingest security data and analyze security data from on-prem and cloud resources so that you can go into Azure Security Center or into Azure Sentinel and you can actually look at one console and you can see security telemetry from your on-prem and your cloud resources. The other thing is that you need to make sure your on-premises fabric is managed and maintained as consistently as the cloud fabric. Now, this is a bit unusual when you're thinking about hybrid, but this is more an exploration of where Microsoft is going. And what I mean by that is in the public cloud, you don't worry about managing the fabric. And what I mean is, for example, if you're running a web application or if you're running a database on Platform as a Service, you don't actually worry about managing the underlying infrastructure. And with products such as Azure Stack HCI, you can actually have your on-prem infrastructure managed by Microsoft. Let's talk about that a bit more. So the Azure elements of a hybrid cloud solution. For management, you can use the Azure portal and Azure Arc, the Azure CLI and Windows Admin Center. So you can use the Azure portal, especially when you've got Azure Arc configured, to do management of on-prem resources. For identity, you've got a variety of options that come with an Azure hybrid cloud solution. You can use Azure AD. You can use Azure Active Directory Domain Services, and you can use Azure AD Connect. And that's all without getting into complex topics such as identity federation. For networking, you've got Azure VPN and Azure ExpressRoute as the products that you use to connect your on-premises resources to Azure. What you don't need to do is you don't need to go, wow, how am I going to connect my on-prem to the cloud? I know what I'll do. I'll spin up my own VPN appliance in the cloud and I'll spin up a VPN appliance on-prem and I'll connect them that way. No, well, we've got VPN as a service with Azure. So you're just connecting into that VPN as a service. For security, as I mentioned, you can use Azure Sentinel, which is a security incident and event management solution, or a SIEM, or a SIM, depending on how you say it. You've also got Azure Security Center. So Azure Sentinel is a way of looking at all of your events and then running queries using Jupyter Notebooks against those to find suspicious activity. Azure Security Center is sort of a pre-built set of configuration alerts and best practices and ways of assessing your infrastructure. So if you want to know that if you're compliant with a particular security standard, such as PCI DSS, you can use Azure Security Center to do that. And in terms of Fabric, there is an increasing number of products available from Microsoft in the Azure Stack range. You've got Azure Stack HCI. Now, what does Azure Stack HCI do? Well, instead of you managing your entire virtualization infrastructure all yourself, where you're installing new Hyper-V servers and you're managing and configuring those Hyper-V servers, what you do with Azure Stack HCI is it's basically a box or a bunch of boxes that you put in your data center where Microsoft is responsible for managing all of the configuration of that infrastructure, and all you worry about managing is the actual virtual machines themselves. And then you've got Azure Stack Edge, which instead of just doing the VMs, which you do on Azure Stack HCI, Azure Stack Edge allows you to run those web apps and all of those Azure services on-prem. So if you're in a situation or a disconnected data center situation, let's say that you're in a submarine or on a cruise ship where you still need to run the sorts of applications that you'd run on platform as a service in the cloud, well, you can run them on-prem. But in that case, Microsoft is responsible managing the infrastructure and you're just responsible for managing the applications. So let's come back to a challenge for Tailwind traders. So Tailwind traders needs to keep a large number of VMs on-prem, but has noticed that maintaining the virtualization fabric that hosts those virtual machines is increasingly challenging. Now, downtime occasionally occurs because the process of applying operating system updates, device driver updates, and firmware updates is a complicated task for hyper-converged virtualization infrastructure. Okay, so how do they solve that? Well, let's go back to what we talked about before. Azure Stack HCI would provide Tailwind traders with an option of a fully managed virtualization infrastructure, where Tailwind traders' IT operations only has to worry about virtual machine workloads and doesn't have to worry about managing and maintaining the infrastructure that supports those workloads. Now, many organisations have already started the move towards a hybrid posture. And as I have mentioned earlier in this presentation, the thing about hybrid when you do it properly is that it improves, it enhances your on-prem deployment. As I said, lots of organisations have already got hybrid cloud. If you've got M365 technologies such as Exchange Online, Teams, or are already using Azure web applications, you're already hybrid. So it's already natural for most organisations to actually understand that they already have a hybrid deployment. And you can be incremental about a hybrid deployment. One of the things that people get wrong about the cloud is they get this idea in their head that it's an all or nothing proposition. You can be hybrid. You can have a little bit of cloud or you can have a lot of cloud depending on what you need. What your organisation should always do is choose the appropriate cloud technologies that are going to make your organisation successful while still keeping those things on premises that you need to keep on premises. So another challenge. Now, Tailwind traders looked at their infrastructure and they did an audit of their Windows Server and Linux workloads, both on-prem and in the cloud, and found that 30% didn't have the most recent software updates installed. Because Tailwind Traders has multiple branch offices spread across multiple geographies, it can be very difficult to make sure that absolutely everything is kept up to date. It depends who owns the workload. Sometimes in organisations that are very geographically dispersed, you get some workloads that are absolutely kept up to date, and other workloads that are basically left without being patched. I can't tell you how many organisations I've gone into where the first thing I do is just check, have you got software updates done? And it's usually not just 30% of server workloads that don't have the most recent updates installed. So one way of Tailwind traders addressing this problem, a hybrid way of Tailwind traders addressing this problem, is using Azure Automation Update Management. And this is another way of thinking about how the cloud or how the hybrid cloud can work in your environment. Because in a hybrid solution, what you can do is you can have your management layer that does all of your monitoring running in the cloud, and you can keep all of your workloads still on-prem. With Azure Automation Update Management, as you can see in this image, you can have Linux and Windows workloads on-prem, as well as workloads running in the cloud, and that you can have one pane of glass, which just basically means one console, to manage updates and compliance for all of those operating systems. So looking at Tailwind traders' next challenge. As with all of us, they've got to make sure that they're compliant with particular standards. And recently they took a long time and a lot of money auditing their configuration of their Windows Server and their Linux workloads to determine if they had drifted from a baseline security configuration that ensured that they were compliant with a bunch of standards such as ISO 27001 or PCI DSS 3.2.1. So how can hybrid cloud help with this? The hybrid solution for this problem is that by using Azure Arc, by using Azure Policy, by using Azure Security Center, Tailwind Traders is able to basically perform an audit on the configuration of workloads and determine whether or not they are compliant with a particular set of security standards. They can then remediate those workloads and ensure that they are compliant. So it's possible in a hybrid cloud scenario to centrally assess the compliance of your workloads. That's something, of course, you can do on-prem, but again, it comes back to this idea of when you adopt a hybrid cloud, that you sort of sit there and you go, you know what we can do? We can actually have our management layer in the cloud where we go and assess all of our workloads, and then we go in and drill down and fix those non-compliant workloads. Now, in terms of hybrid cloud management and governance, Azure Arc and Azure Policy can be used to ensure your hybrid workloads are configured in a specific manner. For example, in a later session, you will see how it's possible to use Azure Arc and Azure Policy to determine whether or not Windows Server VMs are configured to automatically update their anti-malware definitions. You can use role-based access control in a hybrid environment to ensure that only authorized users are able to perform specific administrative actions. Role-based access control is assigning permissions to a specific scope. And in a hybrid environment, you can be very detailed about your scope. You can put your scope as an individual virtual machine or all virtual machines that are running in your environment. Or you can do it to a group of virtual machines or to an app or a group of apps or so on and so forth. Tagging you can use to find workloads related to a specific project. One of the other great advantages of a hybrid cloud is it allows you to simply organize all of your workloads a lot easier. If you've just got an on-prem environment where you've got virtual machines sitting on hypervisors every which way and every which branch office that you've got, it can be very difficult to work out who those workloads belong to. In fact, there has been research that's done that suggests that up to 30% of virtual machines that are running in the world are actually zombie workloads. That is, that they're workloads that don't belong to anybody, that they were spun up and forgotten about. Tagging's really great, and through Azure, by integrating it with Azure Arc in your hybrid environment, you can start to apply tags to all of your workloads, both on-prem and in the cloud, so that you can do a quick search to find where a particular workload works. Now, there's other products that do this, but this is another way that hybrid can make your on-premises infrastructure better. Okay, so another challenge for Tailwind traders. like everybody, they've got file servers. In fact, file servers are the most common type of server in the world. And file servers have a problem. People keep creating new files and they very rarely delete old ones, which means file servers tend to run out of space. And what we all do as IT pros, as administrators, is often we sit there and you go, well, file servers run out of space again. What are we going to do? We need to go and muck out. We need to go and remove old files and put them into long-term storage and just hope that no one's going to ask for those files at some point in future. Because occasionally you get someone saying, oh, look, I left a particular file on a particular directory 3 years ago and I can't find it. Can you go and find that for me because we need it for this new project? File share replication also can cause a lot of problems. Anybody that's implemented DFS on their WAN has found that certain branch offices don't get updated, that there's conflicts, and there's always a whole lot of problems. Well, there is a solution within a hybrid environment, and that's called Azure File Sync. We'll go into Azure File Sync in more detail in a later session, but the idea with Azure File Sync is that you turn it on for your file shares, and then your file shares are automatically replicated up to the cloud. And the cloud keeps a copy of everything. But it's a bit like OneDrive, where with OneDrive, you can basically have you can say, keep this in the cloud, and all it does on-prem is put a little placeholder, and then when you click on the placeholder, it replicates it down from the cloud. Well, if your file sync's sort of like that, and instead of it being like OneDrive, which is just for your client, Azure File Sync works for your server. Anyway, you'll learn more about that in a later session. If Tailwind Traders implements Azure File Sync, they can turn on cloud tiering, and they could turn on Azure File Sync to automatically tier any file that hasn't been accessed for 30 days. So with OneDrive, you've got to do it manually. You've got to say, hey, let's put this folder up into the cloud. With Azure File Sync, it'll say, hey, you haven't touched this for 30 days. Bang, I'm automatically going to go and tier that for you. And if you're a user accessing that file on the file share, you've got no idea whether or not it's been tiered or not. But if you try and open it, what happens is it syncs back down from the cloud and then opens normally. You can also have additional file servers so that file servers all across Tailwind Traders deployment across multiple countries can all have a copy of the same file share. You have a source of truth sitting in the cloud that holds everything. Because remember, cloud file shares can be as big as you want. Your on-prem file shares might only be a couple of 100 gigabytes in size. You can also configure the file share to be backed up every day. And instead of doing the backup on-prem, you just run the backup in the cloud. And if someone deletes a file, well, you come back and you recover it in the cloud, and then that recovered file is available to all instances of that file share. In terms of data in the hybrid cloud, think about it this way. One of the ways that hybrid cloud can really make things better for you is that storage in the cloud is cheap and functionally limitless. I mean, not in reality limitless because you can't put an infinite amount of data up there. But the cloud can act as a store for as much data as you can throw at it. You can put it on colder storage, slower storage, and when you put it on slower storage, it's cheaper to keep, but you can keep a lot of it there so that you can access it when you need to. It might take a little longer to pull down, but you can keep as much data as you want in the cloud. That's a lot more efficient than sort of the old way we used to do it, where we put it on tape and then ship the tape off to an archive facility. And Azure File Sync can be automatically configured to tier cold data that no one's using anymore, to an Azure file share so it's easy and cheap to store. Okay, so we're going to finish this introductory session with a set of best practices and some challenges. So let's start with the best practices. Make sure you're using a consistent set of management tools for your on-prem and cloud workloads. You don't want to have to become an expert in lots of different tools to be able to manage your hybrid environment. You should manage your hybrid environment in a consistent manner. Make sure that consistent security policies are applied to hybrid workloads. It shouldn't be that your workloads in the cloud are really secure and your workloads on-prem are any which way but loose. You should make sure that the same security policies apply to on-prem and to the cloud, that your Linux machines are configured in a certain way, a certain secure manner on-prem and in the cloud, and your Windows machines are configured in a certain way that's secure on-prem and in the cloud. Make sure that backup and disaster recovery is configured for all of your workloads. Don't assume that because you deploy something in the cloud that it's automatically being backed up. It's a big mistake a lot of people make. You know when it's on-prem that you've got to back it up. Why? Because you've learnt the hard way that if you don't back it up on-prem and it fails, you've got no other options. But the same thing can apply in the cloud. And we'll have a session later on about talking about backing up and disaster recovery in hybrid environments. Make sure you track workload costs on-prem and in the cloud. There's tools that allow you to do it in the cloud, but you should also be aware of what your costs are on-prem. When someone asks you how much it costs to run a server or a virtual machine workload on-prem, you should have a ballpark figure in mind to provide them with. You just can't shrug your shoulders and say, I don't know, because then someone will come back and say, well, let's move everything to the cloud, because if you don't know how much it costs on-prem, maybe it's cheaper in the cloud. And maybe it is, but maybe it's not. You need to know how expensive it is to run things on-prem so that you can make a comparison as to how expensive it is to run things in the cloud. Finally, there are some challenges that come with running a hybrid cloud. When adopting a hybrid cloud, make sure that the environment doesn't become so complicated that you can't manage it. There's a thing called cloud sprawl. That is that people get to the cloud and suddenly they can find that they can deploy as much stuff as they want. And that's great until you need to keep track of it all. So you make sure that you limit what can be deployed so that you can maintain it, you can manage it, and you've got a good map of what you've actually got. Make sure that workloads are going to be hosted in the appropriate location from the perspective of cost, governance, and compliance. Don't be like some people who decide, oh, you know what, I'm going to go and put that data in that VM, and I'm going to run that VM in that data center overseas, only to find out that the data within that virtual machine is only allowed to be kept within the country, and that by moving it to a virtual machine that's hosted in the cloud in a data center overseas, you've actually broken some local laws. Now, the other thing to keep in mind, and this is very important when people talk about how moving to the cloud makes things cheaper if you do certain things. Migrating a virtual machine is only the first step in migrating a workload to the cloud, and we do have a completely separate virtual training day on cloud migration. It's eventually necessary to migrate the application to a platform as a service to take full advantage of what the cloud offers. That means instead of running a monolithic application sitting in a VM, you eventually want to get to the stage where it's running as an Azure web app or as a container or as a set of functions or serverless. Anyway, thank you very much for your attention. Okay, in that session, we went through an overview of how hybrid cloud works. We're going to take a break for 10 minutes, and then we're going to get into how hybrid network infrastructure and identity works. Hope to see you there.
Welcome back from the break. In this next module, you'll learn about identity and network architectures in a hybrid environment. This is important for ensuring that network traffic between on-premises and cloud workloads takes an optimal path and avoids the public internet when required. We'll also explore how to simplify your network traffic between different office locations, and finally, you'll learn about the options for using your on-premises Active Directory identity platform to allow access to resources and workloads inside Microsoft Azure. Let's get started. Welcome to Hybrid Cloud Identity and Networking. My name is Sonia Cuff and I'm a Senior Cloud Advocate at Microsoft. In this session, I'll explain how an organization can configure both the networking and the identity components of their hybrid deployment. All of the sessions in this learning path use Tailwind Traders as our fictional customer. This company has a central office and branch offices spread across cities in multiple geographies. Now they use a single Active Directory forest, and their branch offices are connected to one another using a basic hub and spoke topology, with the head office being the hub. There are some occasional direct connections via VPN between specific branches, but these have been deployed over time on a bit of an ad hoc basis. And the exact configuration of this whole networking topology isn't really precisely documented. Tailwind traders will continue to deploy a substantial amount of resources on premises. They have business requirements for keeping some data on-prem, but they'll also continue to grow with their Azure deployment and moving some workloads or maybe even adding some new ones inside the cloud. For the foreseeable future, they need to keep their on-premises Active Directory as their primary source of identity. From a networking perspective, not only do they need to ensure that they have easy connectivity between their branches and their head office into Azure, but also between each of their different branch offices with one another, they need to make sure that those network connections are secure and reliable as possible. So, which hybrid networking and identity model should Tailwind traders use? There's more than one way to configure this, so let's jump in and have a look at your options. First, it's important to start with a list of the business requirements. So the questions Tailwind traders need to answer include things like how do they connect their branch offices to resources and workloads in Azure without making those cloud resources available to the public internet. So even though they're in Azure, we don't want anyone on the internet to be able to connect to those cloud workloads. How does Tailwind traders ensure that network traffic from their specific branch offices to specific workloads and resources in Azure doesn't cross the public internet? So as well as not having those resources open to the internet, they don't want their own network traffic from their branches into Azure to go anywhere near the public internet either. And that's a specific requirement at some of their branch locations. Next, how can Tailwind traders simplify its network topology when routing traffic between its branch offices? Now that they've experienced a bit of growth and they're in a bit of a mess as people have joined a company and created these environments and maybe even left the company, it's time to consolidate and simplify this network topology across all of their locations. And last but not least, how can Tailwind traders restrict access to resources and workloads inside their Azure data centers using their on-premises identities? They've got a significant amount of investment and capital in the user accounts and identities that they've been building up on-prem over time. So they want to keep using that, and they may have specific, say, even line of business applications that require that kind of identity to be used to authenticate into the applications. To help answer those, we're going to look at a couple of different networking technologies and how you can set up a hybrid structure for your identity requirements. Today we'll look at Azure VPN, Azure ExpressRoute, Azure Virtual WAN, and a hybrid identity scenario. Starting with Azure VPN. You may be familiar with configuring a VPN on a network device so that remote workers can log in securely via a tunneled VPN network connection, for example. In this case, what we're doing is we want to create a VPN connection into Azure. You're still going to require a gateway device on premises in your physical location. But Microsoft manages this VPN connection and guarantees 99.9% availability for the VPN gateway service in Azure at the Azure end. It's important to remember that there's no guarantee on the reliability of the connection to that gateway in Azure as it crosses the internet. So there are a significant number of networking components that are outside of Microsoft's control, which could affect that VPN reliability. That's just how networks work. The maximum bandwidth per VPN connection is up to 1 gigabit per second, and it may be necessary to have multiple connections depending on the size of your environments. With this VPN gateway, we have encrypted traffic passing across the public internet. So we're not creating any physical private connections, but we are doing end-to-end encryption on the traffic that's going across the public internet. From an architecture perspective, we've built up a complex picture here of how you could connect this all together. So for Tailwind traders, we have their on-premises environment with their gateway appliance that is going to be their physical end of the VPN connection. Over in Azure, we create an Azure virtual network that has different subnets in it. And so we have a gateway subnet, and that's where the Azure end of that VPN connection sits. Inside our gateway subnet, we have our VPN gateway. Now within that Azure virtual network, we can also create different subnets with network security groups that manage traffic into things like individual virtual machines, or contain things like Azure Bastion for secure remote connectivity to a VM without needing an RDP port open. Now Tailwind traders also have an Azure Stack implementation. So they have a virtual network for Azure Stack with a VPN gateway that passes through public virtual IP addresses and connects through to those same resources that they have in Azure, those virtual machines. So when we're talking about an Azure VPN gateway, it includes the following pieces. We have that virtual network gateway that sits inside Azure, which is a virtual VPN appliance for the virtual network. And this is what routes the encrypted traffic from the on-premises network into the Azure virtual network. Then we have the local network gateway. So that's your on-prem VPN appliance from whichever vendor you choose. And that routes the traffic from the on-prem network into Azure. Now between these two, we have the connection itself. And the connection is configured with different properties like the connection type and a key that is shared with the on-premises VPN appliance for doing the encryption of that traffic. It's important to make sure that your local network gateway supports the connection type that you've configured. And finally, the gateway subnet. So that was the special subnet inside our Azure virtual network that hosts that Azure VPN gateway. Let's look at that a little bit more. The Azure VPN gateway subnets host the IP addresses that the virtual network gateway virtual machines and services use. So we want to protect this subnet. We don't want to deploy any other workloads into this gateway subnet, and we have to name it gateway subnet, all one word, for it to function as this VPN gateway. It's recommended that we use a /26, 27 or 28 subnet, and that we don't apply a network security group to this gateway subnet. Next, I will show you a demo of how we can configure this through the Azure portal and add an Azure VPN, but it is possible to create this gateway subnet through PowerShell with the PowerShell command add-az virtual network subnet config, where we give it that gateway subnet name and the address range. You've learned about the different components of an Azure VPN, so let's go and see what it's like to go into Azure and create one of these. In this demo, we'll look at how to configure a VPN to Azure using the built-in functionality on Windows Server. We've got a Windows Server here, computer name Hybrid Melbourne WAC. So this is a Windows Admin Center instance that we've created on one of our Windows servers. We need to start by connecting this to Azure. So under Azure Hybrid Services, we want to register this instance of Windows Admin Center. It assumes we already have an Azure account, or if we don't, we could click on the link to create one. And it gives us a code to go and copy and a website to paste that copy code into. So we'll add that in and then sign in to our Azure account. We can verify which Azure Active Directory tenancy we're connecting to, and it will create a special Azure Active Directory application to allow us to interact with Azure Active Directory. We need to now sign into Azure with an account that has permission to register an application within that Azure Active Directory instance. Once we accept that, now this Windows Admin Center instance is registered within Azure. Inside the Azure portal, I'm going to a virtual network that I've already configured, and I want to add a gateway subnet to that virtual network. This will be what our VPN connection connects to. I'll give it a subnet address range of 172.16.1.0 with a /24. So that gives me 251 possible IP addresses that I can use within this subnet because Azure reserves 5 of them for its use. Don't need to change anything else, and we'll just get that gateway subnet added. So back in our Windows Admin Center, when we go down to Networks, we want to add an Azure Network Adapter. It's picked up the subscription from my logged in user. I'll select a location for it and the virtual network that I'm connecting to. It fills in that gateway subnet address based on what we created inside that virtual network. And then the gateway SKU is just the size of the gateway that we want. And the different SKU sizes inside this have different capacities and capabilities. Now I need to add the client address space, and I'm going to choose 172.16.2.0, which is adjacent to that other 1.0 address that we had before. And then I just need to click Create. This submits the creation to Azure. It will go and configure a VPN device in Azure, and it will configure the VPN connection on this Windows server. So you can see that it's automating a lot of the process. We haven't had to go into different places and configure things manually. This little wizard, now that we've got our subnet set up, is going to go and do the VPN configuration on both sides of the equation for us. You might think that going to the cloud means putting all of your workloads in the cloud, but there are some business decisions that you have to make based on your particular scenarios. What kind of data are you dealing with? Are there any regulations or compliance around that data, how it's stored and how it can be transferred? And those kind of business requirements influence the design decisions you make about the types of traffic you're happy with traversing the public internet, whether you need to investigate using an Azure ExpressRoute connection, or whether some of the data, the applications, and the traffic to that has to remain on premises. If you do need a dedicated line to Azure that won't go over the public internet, you can look at Azure ExpressRoute as an option. Now that connection can be provisioned up to 10 gigabits per second, depending on the provider who's providing this connection. And it can support dynamic scaling of bandwidth. So you're not always paying for the largest amount of bandwidth you think you might need. You can scale up when you need it. Now, again, this does depend on the capabilities offered by the ExpressRoute provider in your local area. But the key point is that this traffic between you and Azure via this ExpressRoute connection will not pass across the public internet. And because of that, you get this benefit of a 99.9% availability service level agreement of this entire connection. Remember, that's different to the VPN, where Microsoft was only guaranteeing their VPN gateway at their end. That all sounds pretty good, but there are a few considerations with Azure ExpressRoute. For one, it's not available in all locations, so you're more likely to find it in some of the major cities, for example. The architecture itself can be quite complex to configure, and you do have to deal with a third-party connectivity provider. So they are the ones who are provisioning this network for you to use. You also need some pretty high bandwidth networking equipment on your on-premises sites. I did warn you that the ExpressRoute architecture was a little bit more complicated, so let's break it down. To start with, we have our on-premises network. So that's just your standard office location with your VPN appliance as your gateway. Then you have the ExpressRoute circuit itself. So this is provisioned by your provider, and it's a layer 2 or layer 3 network circuit. It joins your on-prem network with Azure through the edge routers. And those edge routers are hardware that is provided by and managed by the connectivity provider. So you have local edge routers on the on-premises side of your network, and then you have the Microsoft edge routers, 2 routers in an active, highly available configuration. You've then got your Azure Virtual Network, and we have a gateway subnet again, but this time instead of having a VPN gateway, we've got our ExpressRoute gateway connection in that gateway subnet. And then different network subnets for your web application and those virtual machines, business applications, for example, and your data storage that are individually protected by network security groups. One of the challenges around a hybrid network deployment will be determining how to route traffic between offices and whether or not each office requires its own independent VPN or ExpressRoute connection into Azure. Now, this leads us in to look at Azure Virtual WAN, which might solve both problems. So Tailwind Traders needs to ask whether their on-premises offices are in multiple regions. Have they deployed resources into multiple Azure regions? Whether each on-prem site should have individual connectivity to Azure, and whether or not those sites need VPN or ExpressRoute connections into each Azure region. You can start to see how all of these different questions and challenges and individual business requirements help you formulate the decisions you make about how this hybrid network topology is going to be configured. With Azure Virtual WAN, we can provide connectivity between two of your different physical on-prem branches through Azure itself. This gives us an automatic site-to-site configuration and connectivity between these on-prem sites and an Azure hub. In essence, it gives us an automated spoke setup and configuration when we step through the processes, and a built-in Azure dashboard to give us some troubleshooting insights and view our connectivity on a larger scale. It's important to know with Azure Virtual WAN, you can have up to 1,000 connections per virtual hub, but each connection has 2 tunnels in an active-active configuration. So it has 2 network tunnels going all the time that your traffic is going to be split between, giving us a level of redundancy, but it means that we don't have a secondary connection that's sitting there dormant, not being used. Also, our on-premises VPN devices can connect to multiple Azure Virtual WAN hubs. We take a look at the Azure Virtual WAN architecture. You can see that we've got the Virtual WAN inside Azure, in essence being our hub and our hub and spoke topology. And our spokes can be anything from our physical on-premises branches through site-to-site connection. Those branches could be connected via ExpressRoute, and we could also have remote users with individual connections from their devices in a point-to-site VPN configuration. Through those, we also connect to our different virtual networks inside Azure, and then all of these different endpoints can communicate with each other. It's time for another demo, so let's jump into the Azure portal and look at how to set up an Azure Virtual WAN. Instead of using a traditional network hub and spoke topology, we're going to use VPN connections from each of our branch site offices into Azure, and then we use Azure as the backbone to connect those sites to each other. This removes the reliance on your one hub site, because if that goes down, it could potentially take down communications from your branch sites to each other. Inside the Azure portal, we'll start in the marketplace and search for Virtual WAN. So it's Microsoft's Virtual WAN offering here that we need to go and create. This becomes the container for all of our network connections. Now we have the standard options here when you're creating any resource in Azure, including which subscription they're being placed in, which resource group, and I've got one I've already created, and then the location of that resource group. So we'll go and change that one to East US. I'm going to give it a name. And here I get to choose what type of virtual WAN. There's 2 types, standard and basic. Now, standard allows for a wider range of connectivity options than basic does, and that includes things like ExpressRoute and user VPNs, known as point-to-site VPNs. The basic type for a virtual WAN only supports site-to-site VPN connections, but it's priced cheaper. We'll leave it as standard for the demo. It'll validate against any Azure policies, and it will go and create that virtual WAN resource for us. Now, I've sped that up. It might not take quite so quickly, but I figured you didn't want to sit and wait for it to complete. Inside the virtual WAN itself, we'll start by creating a virtual hub. So this is your Microsoft Managed Virtual Network, and it contains various service endpoints to allow connectivity. Just note that you can only have one of these hubs per Azure region. With this network topology, your site-to-site connections come into this hub, not into VPN gateways on any individual Azure virtual networks where you have your resources. Again, because we're creating a new Azure resource, we get to pick things like the region. It's given us a default subscription and resource group that we were already in for the virtual WAN. And then we get to put in the particular endpoint connection types that we need. So we'll start with a site-to-site VPN gateway. This allows your hub to have your site-based VPN connections coming into it. And when we create this site-to-site VPN gateway, it's going to ask us for the gateway scale units. Now, this is the maximum total throughput of this VPN gateway. And it always gives us 2 instances for redundancy, but here we've got a maximum of 500 megabits per second of throughput. So you just need to work out this number based on the number of branch sites that you have and their maximum throughputs. For this demo, we're not going to create point-to-site or express route connections, and we don't need to tag it, so we'll go ahead and create it. Again, it'll validate against Azure policy, and there is a warning down the bottom to say that this will take half an hour. I'll speed that up for you so you don't have to wait. So now our deployment has been created. We go and have a look at that hub resource that we've just created. And then we can go back to our virtual WAN and we can see this Alpha Hub listed. Once we have our hub, we're going to create a VPN site connection. This is the Azure side of the site-to-site connection from one of your branch offices. Again, because it's an Azure resource, we need to put the region in. And we want the region where that branch site office is going to be connecting in from, the closest Azure region to that physical location of our on-premises office. I'll create one from Melbourne, Australia, and add in the device vendor name of the VPN appliance. Next, you can turn on Border Gateway Protocol, or you can specify the private address space of that branch site office. Border Gateway Protocol offers dynamic routing, but your on-premises firewall needs to support it. So to keep it simple for this demo, we'll just specify the on-premises private address space of that office. And we want it to connect that hub resource that we just created. I'm going to enter the link name, the internet provider name, and the speed of that particular branch link, and the IP address of that on-premises gateway device. Let's review and create that. And now we have this VPN site set up, so the Azure side of that Melbourne VPN connection. And I can go into Melbourne now, and under these VPN site-to-site connections, I could download the VPN config if I wanted to then go and set up the VPN gateway on premises. I'm going to go and set up a second site though. So let's get Sydney connected in. Again, putting in the name and the vendor of the firewall appliance that's there, creating an address space for it, and connecting it to that same Alpha Hub that Melbourne is connected to. We'll put in a link name, the provider name, the speed, and the IP address of that device in Sydney, and go ahead and create that resource. So now we've got a second site in here, and we can see all the details of that. And if we go back under our virtual WAN and look at our VPN sites, again, we can download the VPN config. So that's going to give us all the information for configuring the on-premises side of these firewalls. In JSON format, you can see that it's got all the information in there about the VPN connections that we need to configure on those devices. So far, we've connected two sites, Melbourne and Sydney, to each other through our hub. Now, if you wanted to create individual devices to connect using a point-to-site VPN, you could use this Create User VPN configuration here and add those kind of point-to-site VPNs. We won't do that for the demo, but instead we'll look at adding an Azure Virtual Network connection. So if you have virtual networks in Azure that have got cloud resources in them and you want those sites to connect, we can add the Azure Virtual Network into the hub so that Melbourne and Sydney can connect to these resources in the cloud too. Add a new virtual network connection and connect it to our hub, and again choose a subscription and a resource group, and connect it to our VNet Alpha, our virtual network that already exists inside Azure with some resources in it. Next, you do have the capability to build some different routing tables and configure different static routes, for example, for more complex networks. We don't need to do that here, so we'll just use a default route table. And we'll create this virtual network connection. Let's go and add another one. We'll call this one Beta, and we'll pick the same hub to connect to. But this resource group and virtual network is in maybe a different Azure data center, and we'll add it to the same route table. Okay, so now we've got two Azure virtual networks connected to our hub with our two sites, and they're all routing with each other via this hub and spoke topology, all inside Azure. Once we have our networking topology figured out, how do we handle identity? If we've got user accounts sitting inside Active Directory in our Windows server on premises, we have a number of options for how we can configure our Azure resources to be able to use those identities. Our options start with our Active Directory domain services inside Azure. So this is where we are deploying servers that are running Active Directory as domain controllers inside Azure as virtual machines, as a separate site, a forest, or a domain. And they're connected back to our on-premises environment and our other domain controllers using a VPN connection. We could also use Azure AD Connect. So with Azure AD Connect, we can synchronize those identities from our on-premise Active Directory into Azure Active Directory. And then the resources we've got inside Azure will use Azure Active Directory to authenticate and authorize those user credentials. It means that the login process happens and the Azure resource doesn't have to try and communicate back to a domain controller on-prem to do that authentication and authorization. Now, another option is Azure Active Directory Domain Services. And with Azure ADDS, it's domain controllers as a service, where Azure provides a service that acts like an Active Directory domain, but you don't have any domain controller virtual machines to manage and operate. With this, we can domain join our virtual servers that are sitting inside Azure to our domain. When we're talking about Active Directory domain servers inside our Azure architecture, this diagram shows Contoso.com having a physical branch with their VPN gateway and their standard Active Directory servers. They connect to Azure through their VPN gateway. And then inside the virtual network in Azure, we have these ADDS servers. We're putting them in a separate subnet, and we're protecting them with a network security group to provide a firewall to protect against unexpected traffic sources. Now, that gateway connection between the on-prem network and Azure provides the synchronization between the Active Directory servers that we have on premises and the Active Directory servers that we're running in the cloud. With this configuration, you are still responsible for sizing the virtual machines inside Azure for these domain controllers and managing them like you would a standard on-prem AD server. Azure AD Connect is a different architecture because we don't have those domain controller servers anymore inside Azure. Instead, in our on-premises network, we have our standard domain controllers and our clients, but we also have a server that is running the Azure AD Connect sync service. Now, it's responsible for transferring the data between the information inside the domain controller in our on-prem Active Directory into our Azure Active Directory tenant. There are some technical details in terms of password hash sync and password write back and how all that works, but this isn't a pure identity session. So if you'd like some more information on that, check out the information at docs on Azure AD Connect. But just briefly, from a sync perspective, we have this automatic sync going on in the background that keeps up to date with changes in your on-prem Active Directory and synchronizes information through to your Azure Active Directory tenant. Your on-prem Active Directory remains the primary source of authority for creating new user accounts, changing details about those users, for example, and it will synchronize those changes through to Azure AD. It's important to note that that sync is never synchronizing a copy of what the user's password is. It's synchronizing a hash of that password. It's demo time again. So let's say that Tailwind traders have a server, a Windows Server virtual machine sitting inside Azure, and they'd like to be able to sign onto that Azure VM using credentials that are inside their on-prem Active Directory. This demo is going to step through the process of creating a virtual machine and enabling it to be logged into using credentials from Azure Active Directory. Now, this is different to using Azure Active Directory domain services, where we would actually domain join that Windows server to a domain. So this doesn't do that, but it still lets you log in with an Azure AD account. Now, that Azure AD account may have been created inside Azure Active Directory natively, or it might be syncing from an on-premises AD environment. There's some important steps that we need during the creation of this virtual machine. So in the Azure portal, we'll go to virtual machines and we'll add a new VM. We'll put it into an existing resource group. So we have one here called Hybrid VM, and I'll give it a name of Server 02. Now, like any VM, we have to pick a region, but the interesting thing here is which particular operating system that we're going to use. It's important to note that there are only two types of operating systems that this particular scenario will work with, one of them being Windows Server 2019. So it has to be a minimum of that Server 2019 version, or it also works if you're creating a Windows 10 VM. We'll leave the defaults here for size and we'll create an administrator account. Remember, with Azure, you can't use administrator as the username, so we'll call it Prime. And of course, we have to put in a complex password and verify it. Now, I'm going to leave port 3389 open. And bonus points if you gasped a little here. It's not a recommended configuration to leave 3389 open on your servers, and you should be restricting network access to that port or leaving that port closed and using something like Azure Bastion for a secure connection. But that's kind of outside the scope of this demo. For now, just to make it easier to connect via RDP to show you some capabilities, we are going to see a few warnings from Microsoft to remind us that opening up port 3389 on this server to the entire internet is probably not the best idea. Then we'll step through the disks and the networking. There's nothing in particular we need to change here, so we'll just leave this at the defaults. And here again for the virtual network and all of these network settings, again, 3389, yes we know. We'll leave it on for this demo. The management tab is where we need to change some settings, and we need to change them when we create this virtual machine. The management tab is where we need to change some settings. Now, the review and create box is blue, which means we could go and just create a VM now with all of these defaults set, but there are two particular settings that we need to change in here. If we scroll down first to identity, we need to turn System Assigned Managed Identity on. This provides an identity for this Azure resource, our virtual machine, inside Azure AD, and it can use that identity to obtain Azure Active Directory tokens. And we also need to turn on Login with AAD credentials. I'm going to turn off auto shutdown because I don't want this computer to turn off, and I can leave the rest as the defaults. Finally, in advanced, there's no specific extensions or anything that we need to install, and I'm not going to bother tagging this demo machine. So now it's going to go through the review process and check that all of these settings that we've put in place for this virtual machine that we want to create aren't contradicting any Azure policies that are being enforced in this place where we're creating it. And when that validation has passed, we'll go ahead and create this virtual machine. So it'll go through and create all the required resources for that VM. And then we can go back to our virtual machines pane and we should see this virtual machine has been created and it's running. Now let's go take a look at Azure Active Directory. You can see I've got a big list of users here. For testing purposes, I've got Gamma user and Jupiter and Mercury, Venus. And if I go and take a look at Jupiter, for example, you can see down the bottom that the source says that this is an Azure Active Directory user. So this account was created natively in Azure AD. Going back to our server, we need to assign some roles. So in the server properties, we want the access control tab. That's where our resource-based access control role assignments are granted. We're going to go and create a role assignment here for the people to log in. Now, the roles that we are looking for are either virtual machine administrator login or virtual machine user login. And the people that you want to be able to log in and have access to the server using their Azure AD credentials need to have one of those two role assignments set in the access control tab on the server that they're logging into. I'm going to do this with an individual user for the purposes of this demonstration, but you could put a group name in here instead and then add the users to that group. So we'll go and save that role for Jupiter. We're giving them virtual machine administrator access, which means that they'll be able to administer that server as part of the server's local admin group. Now remember that adding those role assignments can take up to 30 minutes to apply. So if you go and try and log in to the server straight away and it doesn't work, it might just be that that RBAC assignment has yet to be completed, actually being assigned into the server. I'm going to go ahead and connect via RDP. I've given it some time and sped it up for you, downloading the RDP file and connecting to the server. Now there's a bit of a trick here when you use this connection. When we go connect, we need to click on more choices. The RDP connection has defaulted to the administrator username that we created when we created this VM, but we need to change that and put in a specific format. So we'll choose use a different account, and you just have to be very careful how you format these login details. What you need is Azure AD / as the domain name, and then the full UPN, this unique name of the user's account. In this case, it's jupiter@tailwindtraders.net. And if we put in their Azure AD password and go and log in, it's now going to authenticate with Azure Active Directory for that user, but let me log in into this particular server. Remember, we set up Jupiter as being a virtual machine administrator login. So they've got the option in here to shut it down, but we're going to disconnect from this session to leave the server running. Let's go take a look at a different user account. If we go back to Azure Active Directory, and we'll use Mercury Venus. Now with Mercury Venus, you can see that their source is set as Windows Server AD. So we know that this account was initially created in an on-premises environment inside Active Directory from Windows Server, and it has been synchronized into Azure Active Directory. So similar process, we need to go back to our virtual machine into our access control blade. And this time we're going to add a role assignment in here. So we can see we've still got Jupiter, but we're going to add a role assignment for this other user. So we'll also make them a virtual machine administrator login, give them that role, and add Mercury Venus. And once that role has applied, let's go and test the connection with this user. So remember that this user has been synced into Azure Active Directory from an on-prem Active Directory environment. Again, more choices, and we use that particular formatting using a different account with this Azure AD / and then the unique name for this Mercury user. Now it's going to connect and log us in successfully to the server. The virtual machine user login role, they wouldn't be able to shut the server down. They'd only be able to disconnect their session because, of course, we don't want users shutting down the server thinking that they're logging off and shutting it down for everybody. And that's the end of this demo. You've seen the 2 key things you need to change when you set up the virtual machine to enable this functionality, and then how you need to add the role assignments for the people inside Azure AD that you want to be able to log into the server with their Azure AD credentials. And that works whether they're native accounts or they're synced accounts. This session has thrown a lot of complex terms at you because we've looked at both networking and hybrid identity. What we've ended up though is some scenarios where Tailwind traders can use Azure VPN and ExpressRoute to connect their branch offices to those resources and workloads in Azure without making those cloud resources available to the public internet. They've also explored how they can use ExpressRoute to ensure that network traffic from specific offices into specific workloads and resources in Azure doesn't cross the public internet, that network traffic. And they've now established an Azure Virtual WAN, so they've simplified their entire networking topology, both between their offices and the cloud and between their branch offices and each other. And finally, Tailwind Traders has explored how to use Azure AD Connect and Azure AD Domain Services to restrict access to resources and workloads in Azure data centers using the on-premises identities that they already have. If you're interested in delving into the technical aspects of these concepts further, there are some great resources at docs.microsoft.com. I'll leave them here on screen for Azure VPN and ExpressRoute, the Azure Virtual WAN, and the hybrid identity scenarios. Hey, thanks for your time. I hope this has given you some ideas to explore for how to configure your networking and identity options between your on-premises networks and Azure. We've explored solutions to Tailwind Traders' requirements for network connectivity to cloud resources and for simplifying networking between their branch offices. You've also learnt about the options for using their on-premises Active Directory identity platform to integrate with Microsoft Azure for authentication and access to their cloud workloads. We will now take a 10-minute break. See everyone back here soon, then we will finish part 1 of our event with Module 3, Hybrid Cloud Applications.
Break. My name is Thomas Maurer. I'm a cloud advocate working at Microsoft. And in this next module, we're going to have a look at hybrid compute workloads. And we're going to have a look how we can leverage Azure management technologies to make our Windows Server on-premises environment even better, and how we can actually manage these workloads. So let's have a look. In this session, we're going to talk about hybrid compute workloads and how companies can take advantage of the cloud in an on-premises environment or in a multi-cloud environment using our hybrid services. For this session, we're going to take advantage of our demonstration company called Tailwind Traders, which actually represents everyone and no one at the same time. And we will run through a couple of demonstration scenarios to show you how Tailwind Traders can make their on-premises environment even better using the cloud. Now, before we actually start and have a look at all these solutions, I quickly want to give you a little bit of background what Tailwind Traders has on requirements and why they are in a hybrid cloud environment. So first of all, Tailwind Traders is already in a hybrid state. They are currently moving workloads to Azure, but some of their workloads need to be on premises, right? There are multiple reasons why these workloads can't be moved to the cloud. They have them running in their local data centers, at their branch offices, factories, or retail stores. And again, these can be scenarios where they have data sovereignty challenges, or networking issues, or latency issues, or no network connectivity available to an Azure region, right? So there are reasons why they want to use a hybrid cloud environment. Now, the next thing they want to do actually is they want to take advantage of the Microsoft management tools for their hybrid environment. They want to use a single set of tools for their workloads running in Azure or in multi-cloud environments and also on premises. They don't want to separate all these tools and use different tools depending on where these workloads are running. And we're going to have a look in this session how you can use basically the same tools, the same control plane for your workloads running on premises, in Azure, or even at another cloud provider. So in this session, we're going to have a look at how Tailwind traders can decide which hybrid management and monitoring tools they should use in their environment. Now, we're going to have a look at some of the example requirements, right? So we're going to go through a couple of different scenarios. So the first one is we're going to have a look how Tailwind traders can actually manage their Windows Server workloads with a consistent experience across their hybrid cloud environment. We're also going to look how they can apply policies to their compute workloads in a hybrid environment. And we're going to have a look at how Tailwind traders can simplify the management and maintenance of their on-premises virtualization fabric, as well as how they can make their file servers more efficient, taking advantage of the scale of the cloud. And then also, last but not least, we're going to have a look at backup and disaster recovery strategies for their Windows Server workloads in a hybrid environment. So we're also going to have a look at a couple of different tools and services. And again, just in case of time, we can't hit all of the possibilities we have in Azure and with our Microsoft tooling. However, we will have a look at a couple of different technologies and services. So we're going to start a little bit with Windows Admin Center, which is our new web-based server manager, if you will, and allows us to manage Windows Server as well as, for example, Azure Stack HCI. We're also going to have a look at Azure Arc-enabled servers, which lets us connect on-premises servers or servers running at another cloud provider to Azure Resource Manager, so we can take advantage of the Azure control plane and start onboarding Azure management services, such as, for example, monitoring. We then also have a quick look at Azure Stack HCI, which is our hyper-converged infrastructure, and how you can leverage that for your on-premises deployments. We're also going to have a look at Azure FileSync, again, taking advantage of the cloud for our file servers. And at the end, we're going to have a look at Azure Backup and Azure Site Recovery when it comes to our backup and disaster recovery strategies. So let's get started with Windows Admin Center. Windows Admin Center, you can see here a screenshot, is a web-based management console to manage our Windows Server infrastructures as well as clusters, Azure Stack HCI deployments, and so on. Now, this is not something running in Azure. This is something you can download and can install that on premises on your Windows Server or, for example, on your Windows 10 machine. And then it allows you to do remote management of your servers using PowerShell remoting in the background. Now, Windows Admin Center at the same time lets you do a couple of management tasks, like all the regular things you need to do, like device management, event viewer, the new performance monitor, and much, much more. But it is also the gateway to the cloud, right? It allows you easily and simply onboard Azure services like Azure Backup, Azure FileSync, and many, many more to your Windows Server environment. And we're going to have a look at that, and we're going to do most of our onboarding using Windows Admin Center. That said, you can also onboard your Windows Server environment without Windows Admin Center. So if you don't have it in your environment, you can still do that as well. However, Windows Admin Center is free. It's a free download. So if you have Windows Server, you can just go out and download it. and then start managing your environment from Windows Admin Center. It then also helps you to do like remote desktop and PowerShell session to the servers you manage. So as I mentioned in the backend, it's using PowerShell remoting to manage these servers. So you can also leverage that. So if there is a tool missing or something like that, you can still go in and just do a PowerShell connection directly from Windows Admin Center. And I mentioned that this is something you can install locally. However, in a new preview, we also allow you to use that directly within the Azure portal. So you can basically go out and if you're having Azure virtual machines, you can use Windows Admin Center directly within the portal as well. Again, that is preview, and we're going to have a look at that later on. So now I mentioned that Windows Admin Center can run locally. So this is our on-premises deployment. So one thing we can do is we can obviously then manage with Windows Admin Center our local servers, right, in our on-premises environment. But then we can also go out and say, hey, we have a couple of Azure machines and we also want to manage these directly from our Windows Admin Center. So we have something called the Azure Network Adapter, which allows us to create a point-to-site VPN connection from our Windows Admin Center to our Azure Virtual Network, and allows us then basically to manage some of our VMs running in Azure. Again, this is great if I don't have a site-to-site VPN or express route in place, but I have a couple of machines in Azure I want to securely manage from my local Windows Admin Center instance. We can also install Windows Admin Center in a virtual machine running in Azure, and then basically manage our Azure VMs, or also even go backwards and manage our on-premises machines directly from Windows Admin Center running within Azure using a VPN connection or express route, depending on what our setup looks like. So let's have a quick look at the demo of Windows Admin Center. Now here we are in Windows Admin Center, and you can see here it's a web-based UI. You can see in the middle I'm already at the networking tab. On the left side you see all the menu with all our tools and extensions, as we call them. So you can see here I have, for example, device manager, I have events, I have files, firewall settings, local groups and users, PowerShell connections, processes, you name it. And there's much more available here. Now, I can also use that for multiple users, so I need to install it once, and then multiple users can actually connect to that gateway. Now, what I want to show you in this demo is that I can actually create here a Azure Network Adapter. Now, you can already see that this Azure Network Adapter is connected. So I already have a point-to-site VPN connection to my Azure Virtual Network running, and so my Windows Admin Center server actually can connect to that machine. So what I can do here, if I switch back to my management experience, I can see here all my servers and I can add a new connection. So if I click on add, I can then quickly see I have an Azure VM here with a private IP address 10.0.2.4. So I can enter that here. And this will now detect our server, and I can click on add. Again, this is now using a point-to-site VPN connection through Azure to add that server. And if I click on that server, you can see here now I can start managing that server. I get some information here. I get some overview about that server. I can see what operating system it is running. And on the left side, you can see here all the tools I can have. So one thing I want to do here, I want to install a couple of roles and features here. So I'm going to install the DNS server feature. So instead of connecting to the server using RDP, I'm just going to select here that in Server Manager. And then I can also go out and have a look at, for example, other features as well. And you can see here, I can basically go through and install all the feature services and features or roles and features I want to. So I'm also going to install wins because it's wins and not lose. So I can click on install. This will then quickly check all the dependencies as I remember it from Server Manager. and then just click on install, and this will go out and now remotely run the PowerShell commands against my server running in Azure to install the DNS server feature role, as well as the Wins server feature and so on, with all the dependencies. So this will take a couple of minutes, as it would usually take. And after they're successfully installed, I can then go out and have a look at extensions. So we have a preview extensions here for DNS management. So you can see here, this is like basically the extension to manage DNS. So I'm going to install that. And after that's successfully installed, it will reload. And now I can switch back to my server where I just installed the DNS server feature. And now I'm able to use the DNS extension here to actually do my management tasks on that DNS server. So as you can see here, I can now go and create a new DNS zone. So let's create a new primary zone here, call it Tailwind Traders.hybrid. Let's create. And now the zone is created. Now let's do a quick double check. So if I go and have the RTP connected to that server, I can first go to tools, and you can see here I can open up DNS because this is obviously a DNS server. So you can see here the feature at least was installed. If I go to the zones here, you can see here's my primary zone for Tailwind Traders.hybrid. So you can see here that I have a great way of managing servers remotely using Windows Admin Center. And with the Azure Network Adapter feature, I can also easily connect to an Azure Virtual Network and manage my servers from my on-premise Windows Admin Center within Azure, which is pretty cool. So for the next part, I quickly want to talk a little bit about how the Tailwind Traders environment gets increasingly complex, right? So we actually had a look at why their environment gets more and more complex, and we discovered three main reasons why this is happening. And I'm sure this also happens to many, many other companies and even real companies outside in the real world. Now, first of all, IT or IT admins and developers, they need to manage hundreds, if not thousands, of different applications. Some of these applications are modern applications written in modern languages like .NET Core and many others. They're running on PaaS services, serverless, containerized, and so on. However, what we also can see is that obviously we have a lot of traditional applications running on virtual machines or even physical machines, right? And IT needs to take care of all of that. Now, another thing we are seeing is that, and I mentioned that before, there's a very diverse infrastructure, right? So companies have their own local data centers. They have some outsourced to local service providers. They're using branch offices. They have factories. They, in some cases, use different OEM hardware. They have IoT and many, many other things they need to take care of. And usually these end up in having multiple management tools and multiple access tools to manage that infrastructure. And then last but not least, there's also multi-cloud, right? So a lot of companies or many companies are in a multi-cloud environment. Even though, for example, they decided to go with Microsoft Azure, there are other companies which already have other cloud providers onboarded, right? So for example, from the past in history, they start with another cloud provider, one department did that, and they're not going to migrate now everything over. Or other companies, for them, it's really a strategy to have multiple cloud providers. But again, this means also that you have need additional management resources, right? Now you're not just dealing with one cloud provider and the tools of one cloud provider. Now you need to deal with multiple of those. And we want to address that to make it easier to manage everything with a single control plane. And we kind of have that. So if we look at Azure, Azure has a very good control plane. So this is a high-level architecture view of our Azure management services. So let's start on the left here. So we as Azure customers, when we interact with Azure, we're using the portal, PowerShell, the Azure CLI, APIs, the SDKs, and so on. And what we are doing is we are interacting with Azure Resource Manager, which is basically the magic behind all the Azure management tools and experience. So what we have there in terms of security or access, when it comes to role-based access controls, logs, subscription management, policies, blueprints, tags, search and indexing, everything you need for inventory or organization, that is basically done by Azure Resource Manager. And then we also offer on top of that a couple of management services for monitoring, update management, backup, disaster recovery, security, and many, many more. And until we announced Azure Arc, Azure Resource Manager and these management services were mostly designed to manage Azure resources, right? So what we did with Azure Arc, we actually extended the Azure control plane with Azure Resource Manager to allow us onboarding services which live outside of Azure, right? So as of today, with Azure Arc, we can onboard servers, Linux and Windows servers. We can onboard Kubernetes clusters and data services to actually take advantage of that single control plane we get within Azure. And we're going to have a look at that, how that looks like right now in this demo. So here I am again back in my Windows Admin Center installation. You can see here all my servers listed. And what I'm going to do here is I'm going to connect a server to the Azure Resource Manager using Azure Arc, the Azure Arc feature. So let's have a quick look. So we're going to select our server 4 here. I'm going to manage that with one of my local credentials here. I'm going to connect. And as you saw before, we can now manage that server. And we could do some management tasks here. However, we will scroll down to settings. And in settings, we can now simply onboard our server to Azure Arc for servers. So what I'm going to do, I'm click on Get Started. I'm then make this a little bit smaller here. I select the right subscription and the right resource group. I want to add that server. I can then also select the Azure region I want to connect that server to. This is only for the metadata connectivity of the Azure Arc agent. And then I can also basically use a proxy server if my server is behind a proxy. So when I click on setup, this will now set up the Azure Arc server. So it will download the Azure Arc for Service agent. It will install that agent and then will register my server with Azure. So when this is done, my server will basically show up in Azure as an Azure resource. So here it's now connected. What I can do right now is I can click on view this server in Azure. Open that link. And if I do a quick refresh, you will now see here that I can see here my Azure Arc enabled server I'm just joined. It's now a Azure resource. So I can see it now in the Azure portal. You can see here it looks like an Azure resource. I can do a couple of things. I can do extension management. But let's have a look at one of the features called Insights, which is a monitoring feature. So what we can do here is we can enable Azure Monitor for that server. So I'm going to enable that. This server then needs to be joined to a Log Analytics workspace. And then I can enable the Azure monitoring feature for that server. Again, this server is running locally here in my own Tailwind Traders data center. This, again, will take a couple of minutes to connect everything to make sure that the agents are installed at the right way and registered to the right Log Analytics workspace. And after a couple of minutes then, I can now see my server coming up here. So what I want to show you here are a couple of things. So first, let's have a look at performance. So here I get some performance monitoring data. I can see how much disk space there is, CPU utilization of that specific system, memory utilization, if you will. I can see the IOPS and disk throughput of that system, as I can do with Azure Monitor. I also have logical disk latency, percentage used, and then also some network information in terms of how much bandwidth I used with my server. I have a couple of other tools here available as well, and I want to quickly highlight that as well. So another thing is the dependency map. So with the dependency map, you can see here, I can actually see to what services or endpoints is my server connecting to. So I get, for example, the information that my server here is connecting on port 445 to one server here, which is a local server or a local IP running in my own location. However, I can see that for many, many other systems as well. And that really helps me to see, hey, what are the dependencies between the different systems? And why is my server connecting to that? I can then also build security monitoring on that if I want to. And I can get much, much more out of that. Now, Azure Monitor is just one feature which is embedded into Azure Arc enabled servers. And there's much, much more when it comes to that. So this was the Azure Arc enabled servers demo. Let's have a quick look at the architecture here. Now, what we have seen here is that we actually connected our on-premises server, again, this can be a Linux or Windows server, to Azure. And then we onboarded that to the Azure Resource Manager, and then we can onboard services like Azure Monitor, Azure Policies, Update Management, and so on, like we would do with an Azure VM. Now, again, as I mentioned, there's much, much more you can do with Azure Arc enabled servers. And I want to give you a quick key takeaways, what we actually can do. So with onboarding servers to Azure Arc, we can actually get an inventory of all of our Windows and Linux servers, physical and virtual machines running in our private data centers or hosted clouds, and it's completely domain agnostic. I can also take advantage of the governance and security tools in Azure, and we're going to show you more in this training as well. So you will be able to use built-in policies to manage Azure and Azure Arc enabled servers. We will take advantage of Azure Security Centers and security baselines. So you get basically one view to see all of your compliance or your compliance overview. You get role-based access, so you can actually get access to the different servers you want to. And if you're a managed service provider, you can also combine it with Azure Lighthouse. And then last but not least, obviously, by adding that server, you get basically a searchable inventory and an experience in the Azure portal, which you can also leverage, by the way, using CLI or PowerShell or whatever you're using to actually get the data from the Azure from Azure. You can then get through it and see an overview of all your systems. Doesn't matter if they're running in Azure, on premises, or at another cloud provider. And then you can take advantage of tools like, for example, tags to manage these servers and organize these resources. So the next thing I want to talk about is extending the virtualization fabric or modernization of the virtualization fabric of Tailwind Traders. And for that, I want to talk about Azure Stack HCI, which stands for Hyperconverged Infrastructure. Azure Stack HCI is part of our Azure Stack portfolio. And again, Azure Stack is not just a single product or solution anymore. It's now a set or a portfolio of products, if you will, with Azure Stack Hub and Azure Stack Edge. And when it comes to our hyperconverged infrastructure, we have Azure Stack HCI. And Azure Stack HCI offers a couple of different features. And so let me quickly talk about this. First of all, it's our hyperconverged infrastructure stack. It's now we have now a specialized host operating system. It's based on Windows Server, but we took everything out which is not needed as a hyperconverged infrastructure. So everything is not needed for virtualization, networking, storage. We have taken that out, and we have built in additional new features, like for example, stretched cluster, so you can have an active cluster over multiple regions, faster resync of storage spaces, and then also integrated, for example, full stack updates with our OEMs together, so you can actually go out and run an update over all of it. We also deliver it now as a Azure service. So that means it's natively integrated within Azure. So that means no agent or anything to install. Azure Arc is basically built in to the Azure Stack HCI operating system. And then you can manage it through the Azure portal if you want. You get the great Azure support with a dedicated support team in Azure. And you also get your billing over Azure itself. So you will have an Azure subscription, and that's what basically your billing information goes against it. We also will offer self-service VM creation, so you can then actually go out and create your virtual machines on your local Azure Stack HCI installation directly from the Azure portal with the same experience. And again, think about role-based access and other things which come in very handy when you do that. But this is not a complete new experience. So you can also leverage your existing skills and knowledge you already have of managing Windows Server and your infrastructure. So you can actually go out and customize the hardware of your choice, right? So we have a huge catalog of Azure Stack HCI validated hardware together with our OEMs, where you can pick and choose and build it in the right size you actually need it. From very small 2-node clusters, for example, for your branch offices, up to very high performance 16-node and large scale clusters as well. You can use the familiar tools like Windows Admin Center, System Center, PowerShell, third-party solution like Altaro Backup, for example, and you get full access to the Azure Stack HCI, full administrative control over that. So if you need to install something or need to change something, you can actually go out and do that. So we want to talk about file servers now. I think everyone got them and everyone needs to manage them, but they have been here for years, but it's time a little bit to modernize them. So I want to give you an example of the Tailwind Traders environment here before I actually go. I'm going to show you a demo here. So first of all, Tailwind Traders has a file server in New York where users and applications are accessing these files. What Tailwind Traders did is they connected that to an Azure file share using Azure FileSync. And that gives them immediately one benefit, and that is cloud tiering. So they can now say, okay, I want to only keep files which are younger than 2 months, for example, on-premises storage, and everything else gets offloaded to the cloud. However, the files still show up on the local file share, but when a user clicks on it, the file will be downloaded from the cloud, so you can actually save some disk space. You also get now cloud access. So instead of, for example, the need of accessing that local file server, users working from home can now access that file share. We also get multi-site sync. So they also want to have the exact same files available in their Seattle office. So they can just add a second server to their Seattle office and synchronize these files over the cloud using Azure FileSync. And while these files are already on this file share, they can take advantage of Azure Backup, which then can just back up that file share. And in case you need to restore something, you can easily do that in Azure. And again, Azure Backup is a great service. We will talk a little bit more about it soon, but it gives you, for example, 99 years of retention, so you can store it for a very, very long time. It's very cost effective, so very great service. And then another scenario here would be rapid file server disaster recovery. So what happens if the file server in Seattle crashes? So usually Tailwind Traders would send home all their employees. No one would be able to access that file server anymore. And then would just wait until they set up a new server, they reinstalled everything, and they started to restore all these files. Now with Azure File Sync, they can just basically spin up quickly a new server. Let's say it's called server 3. They can go out and install the agent, and the agent will now register again with the Azure File Share. It will download the metadata. So in a couple of minutes, all the files will appear again on server 3. Now for the user, it looks like all the files are already back. However, when they click on a file again, it will download the file from the file share over the internet in the background. So you don't need to wait until everything is completely restored. You can immediately let users work again. So let's have a look how that can look like in a little bit more advanced architecture. So when we have our on-premises environment on the left and our Azure environment on the right, you can see here I have on-premises, I have a domain controller, and I use Active Directory AD Connect to synchronize my identity with Azure AD. And then on premises, my clients are actually accessing, for example, different file servers. In this case, it can also be just one, but like in many cases, you have multiple file servers in different locations. And what we are doing with Azure File Sync, we are basically synchronizing these with an Azure file share living in Azure. Now, an advantage now is also that now clients which are not in the office, which are not next to a file share, they can now access the Azure file share from wherever they are. Again, if you enable that feature, so you can actually enable them from working from home with that file share. So actually great solution here. So let's have a quick look at the demo here of Azure File Sync. So here I am in Windows Admin Center again, and I already prepared a file server here, which I want to connect to Azure, to an Azure file share using Azure File Sync. So I click on File Server 1. And now what I'm going to do is I'm quickly have a look, what files do we have here? So we have a built-in file explorer in Windows Admin Center. And I can see here on the E drive, I can see here I have a folder called Designs with folder A, folder B, folder C, and folder D with a couple of files in it, right? So you can also have a look at the file share. So you can see here we have a file share called Designs, which I actually share these. And so what I want to do here on file server 2, I want to have the same look I had on file server 1. So here I have a file share called Designs as well. Now if I have a look at the files here, you can see here my E drive again, I have a folder Designs, and you can see here this is empty currently, right? So I don't have any files on file server 2, but I want to have the same files from file server 1 on both file servers available at the same time. So I go back to file server 1, and I'm going to set up Azure File Sync. And again, this wizard will help me to set this up. So I'm going to select the right region for my file sync. And you can see here, I want to edit the resource group, for example. So I create a new Azure resource group for my file share. I create a new storage sync service, and this will then also go out and create all of these resources. So it creates my Azure resource group, my sync service. It will download the agent for the Azure File Sync and will register that server with Azure. So after that is done, my server is now set up and connected to that sync service. However, I did not sync a folder yet. So I need to go out and select the folder I want to sync. So on my E drive, we now provide the name of that folder. So you can see here it now shows E Designs, and then I can enable tiering if I want to, and then I can configure how much space I want to keep free. I then also configure that for a sync group. give that sync group a name because I want to join the other server to the same sync group. I create a new Azure file share to sync that server, and that means also I need a new storage account. So I'm going to create that. And again, Windows Admin Center does all of that for me. I can do the same thing in Azure without Windows Admin Center, but Windows Admin Center really makes it easy for me to onboard Azure File Sync. So you can now see that we also have that sync set up and that tiering is enabled, and that folder is actually syncing. So if I go to my Azure portal, if I go to resource groups, you can see here I have my hybrid file share resource group, and I have a couple of stuff in there. I have my sync service as well as my storage account. If I go to my storage account, I have a file share. In that file share, you can now see all the folders with the files I synced from file server 1. So the next thing I want to do is now I want to have the same files, obviously, not just in Azure, but also on my file server 2. So I'm going to set up the same thing on my file server 2. This time we have some small differences because most of the stuff is already created. So it already selected the right resource group, the already existing storage sync service. It installs the agents and registers that server. Now, again, I need to now add which folder should be synced. So I can actually select my folder here and then also say, okay, I want to join that sync group. So let's do e-designs. And then again, select the existing sync group this time, the existing storage account, and just set it up. And now it says successfully synced that folder. So if I now go back to the files, you can now see here, I have the same folders available and same folders and folders available on file server 2 as well. So I want to show you one thing here, that all files are available right now. So if I create a new folder, I can create folder E. And now that folder is created. There's obviously nothing in there. But let's create another folder here called subfolder, just so you see that there's no issues. So let's go back to Windows Admin Center. And now we go to file server 1. And now we want to see if the same folder is now on server 1 as well. So I'm going to my file share drive. And now you can see here, I have folder E now also available on file server 1. So this is a great sync. We're basically now syncing these files and folders over Azure between different servers. And so we always have the same files and folders available on all of our locations of Tailwind Traders. So the next thing I want to talk about is Azure Backup. Now, Azure Backup is a great quick win for Tailwind Traders environment. So what it allows us to do is actually simply not just backup and restore services in Azure, but also do that in a hybrid environment. It basically automatically allocates and manages the backup storage in the background, so you don't need to take care of that. You don't need to add more storage to the backup pool and stuff like that. You basically have unlimited scale available with local redundant storage and geo-redundant storage. Again, depending on your requirements, you can choose which one works better for you, or what are your requirements. And this also obviously depends on the price you want to spend. And then there is no charge, by the way, for data when you need to restore, right? So you obviously, if you're familiar with Azure, usually ingoing traffic to Azure is free, and then outgoing traffic to Azure, there's some cost involved. We don't want to charge you if you restore a backup, right? So we don't do that in terms of when it comes to Azure Backup. And you have a pay-as-you-use model, right? So you only pay for the things you actually need an op for the storage. You don't need to pre-reserve storage or anything like that. You can just pay, and as soon as your storage grows, you obviously will also pay more automatically. Everything is encrypted. So when it comes to like data in transit from your on-premises machine to Azure, this is encrypted. Your on-premises to Azure backup, the data in Azure, which is encrypted at rest with a key phrase we will set up when you set up the backup, and we'll show you that in a quick demo. So you bring basically your own key phrase. And then for Azure VMs, for example, the data is encrypted at rest using the storage service encryption. Now, I also want to say there are some other features and properties with Azure Backup. So you have, for example, an application consistent backup. You have no limited amount of time data is stored in your recovery vault. You have a limit of 9,999 recovery points per protected instance. And then you have multiple options depending on what you need when it comes to Azure Backup, right? So for example, you have the Azure Backup agent, which you can actually go out and just install an agent on a Windows 10 machine or on a Windows server and then back that up. If you need to, for example, need to back up multiple systems or also applications, we have also something called the Azure Backup Server, which you can basically download and install for free on premises. And then you can do a short-term backup on that backup server and then offload the long-term backup to Azure. Azure Backup is also the service which basically backs up your Azure infrastructure as a service virtual machines, including, for example, SQL and Windows IaaS VMs. And then, as I mentioned before, it also can back up your Azure file shares as well. There's also more. So if you, for example, look at Azure Backup Server, it can back up and restore VMware VMs as well, Windows and Linux. Again, same thing, by the way, for Hyper-V VMs. You can back up files, folders, volumes, VMs applications like Exchange or SQL or SharePoint. And you can also back up like the system states of servers as well. It then backups basically to local attached disks for short-term storage. So if you need to back it up and then quickly restore it, you can do that directly without anything. But then for the long-term storage or also off-site storage, if you will, we have the Recovery Service Vault in Azure. Also mention quickly, because we get these questions a lot, it also does application-aware snapshots using VSS. It's full flexibility for when to take the backups. So you can completely configure that yourself. And you can also have a recovery granularity depending on what you actually want to recover. Now, if you look at an Azure Backup architecture, what we can see here, for example, we have an on-premises environment. We have a couple of workload servers like SQL, SharePoint, Exchange, file servers, and domain controllers. And then what we did here in this scenario, we installed a Azure Backup Server, which will actually back up these workloads. And then you can send them through Azure, again, over the internet or over ExpressRoute, or use even the Azure import and export service to actually, like when you have a big chunk of data you want to move, you can, for example, also leverage that as well. And then this will be stored basically in the Azure Recovery Vault, which will manage the storage in the background. We use Azure Storage for that. And then you can also replicate that to a secondary Azure region to make that like disaster recovery basically enabled if one of the Azure regions should go down. So let's have a quick look at Azure Backup. So here I'm back in Windows Admin Center. And what I want to do here is I want to back up the files on one of my servers here. So as you can see here, I click on my file server 1, which we used before. So if I quickly have a look at the files on that server, I can see here that I have my E drive. I now have a folder called Research. And in that folder, again, I have folder A, folder B, folder C, folder D. And now I want to configure Azure Backup to actually back up the folders and the files on that machine. So what I can do here is I can simply click on Setup Azure Backup. And this will then go out and ask me for my user account. It will also set up the Azure Backup for me. And then it will ask me, what do I want to back up? Now, in my case, I just want to back up the files on my E drive. And then here I can go out and I can select the retention rate and the schedules basically of the backup. So in this case, very simply, I select one of the pre-configured ones, daily, retain 30 days. And then I can enter my passphrase, my personal one I want to create. This is very important. If I need to restore files, I will need that passphrase. So make sure you save that on a secure location, because we can't help you restoring that. So now it sets up Azure Backup. It will install the backup agent in this case, and then will automatically configure the backup as I configure that. Now, it's obviously going out at a specific schedule, but I can also trigger the backup. So I'm going to trigger the backup to create a recovery point right now. This will start the backup and will take a couple of minutes to complete, especially because this is the initial backup. So on the jobs, I can actually see what is going on here. So if I refresh, you can see that at the moment, data is now transferred, and basically the backup is now completed. So I have now one recovery point basically of these files. So if I click on that, you can see here when this recovery point was created. And again, I can do that for multiple times, obviously. Now I go back to my files here. And what I'm going to do here in my research folder, I'm just going to now accidentally delete folder D. So folder D is now deleted with all the files in there. Now let's switch back to my server to actually show you that. So I'm here on that server. And if I go to my E drive, you can see here I have my folders research. And again, you can see folder D is gone. Now I want to restore that. I can simply open up the Azure Backup console here. And you can see here I can find the same information here. And now I can click on recover data. I can say, okay, I want to recover from this server, just files and folders. So I don't want a whole drive. I just want to have some files from that. You can see here, it was bold marked my last recovery point. You can also have, again, if you have multiple of these will show. And now it will basically open up that recovery point and mount it. And now I can go and see that mounted recovery point. So if I click on it, you can see here folder D is now here in this recovery point. So I can do a copy and then simply go to my server, go to research, and then basically just go and paste folder D back. And so my folder D is now restored. I can also unmount the recovery folder or the recovery mount point, and my files are available again. So this was Azure Backup. Again, there are multiple scenarios you can use that. However, there is even more. So we can also leverage this, Azure Site Recovery for disaster recovery. So what we can do here is we can actually replicate physical and virtual machines running on Hyper-V and VMware to Azure to then actually have a failover region basically available. So in this scenario, I'm going to show you here with Azure Site Recovery. You can see on the left side, I have my on-premises environment, which is basically, for example, in this case, a web app. So we have a IIS web server and we have a database server, and we use Azure Site Recovery here to replicate it through Azure. And in case of a disaster, we can then go and failover our virtual machines to Azure. So in this case, you can see on the right side, it would then have my web server and my SQL server restoring or recovering in Azure. And if we then have a service in front of it called, like, for example, traffic manager or front door, or depending on your architecture and your scenario, in this scenario, we would have, for example, traffic manager. We would just basically switch the routing, the DNS routing, to from the location from our on-premises primary side to our Azure failover side, and the application would be available for the end users again. So absolutely great service. So let's go into a quick summary. So what we have seen so far is how Tailwind traders can use Windows Admin Center to consistently manage Windows Server workloads in a hybrid cloud environment. So you can take advantage of Windows Admin Center. You can basically go out and use that today. Even if you're not working with Azure, Windows Admin Center is a great management tool for Windows Server. We also saw how Tailwind traders can take advantage with Azure Arc and basically connect servers to the Azure control plane with Azure Resource Manager and manage them if they're running in Azure, on premises, or even at other cloud providers. We also had a quick look at Azure Stack HCI, our hyper-converged infrastructure solutions, which is a great solution if you do virtualization in your own data center. We had a look how Tailwind traders can make their file servers more efficient using Azure FileSync. And then we had a look at how Tailwind traders can take advantage of the cloud for the disaster recovery strategy using Azure Backup and Azure Site Recovery. So here are some additional resources. So again, I spoke about Windows Admin Center. I spoke about Azure Arc enabled servers, Azure Stack HCI, Azure FileSync, Azure Backup, and Azure Site Recovery. So we put all the links here together for you. So you have aka.ms, and then depending on the technology you want to have a look at. You can also follow our team, so make sure you check out itopstalk.com. You can also follow us on Twitter on itopstalk. So this concludes part 1. So let's have a quick recap on what we have learned so far. First, we had an overview about hybrid cloud computing. Then we actually had a look at hybrid networking and how you can connect your on-premises environment to Azure using site-to-site VPN, ExpressRoute, and much, much more. In the third module, we have learned how we can leverage Azure management technologies to manage our hybrid compute workloads. So thank you for your attendance of this first part, and we're looking forward to have you in the second part of our Microsoft Virtual Training Day implementing hybrid infrastructure.
Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi and welcome to the second section of our Azure Virtual Training Day on hybrid cloud infrastructure. Today, we've got two sessions to talk about. The first, which I'll go into in a minute, is all about hybrid cloud applications and data. The second is about hybrid cloud security. So, in this session, we're going to talk about hybrid cloud applications and data and how you can think about where do I put different tiers of the application. Do I put it up in the cloud? Do I put it on-prem? And what are the things that I need to think about when I'm actually doing that? Let's get into the session. In this session, we're going to talk about hybrid cloud applications. So Tailwind Traders has a number of applications that they're going to have to think about what they're going to do when they move to this hybrid posture. Some of the applications, it makes sense to move entirely to the cloud. And some of them, for a variety of reasons, they want to keep the data on-prem. Maybe they want to keep the application on-prem. So in this session, we're going to talk about all of the hybrid technologies that you can use with applications to make them work. Not just migrating the entire application lock, stock and barrel to Azure, but instead how you can have a hybrid application where parts of the application might run in Azure, parts might run on-prem, or where the application runs on premises but is accessible to clients out on the internet where they access that application through Azure. So let's talk about Tailwind Traders' hybrid cloud application requirements. Basically, their hybrid requirement is that they need to keep some workloads on premises and move some workloads to Azure. And there's a variety of reasons for this. Some of the data that they've got stored on premises needs to be kept on premises simply for regulatory reasons. They can't go and put it into the public cloud. And there can be a variety of reasons for that. This is definitely something that you have to deal with when you are living outside the United States. And of course, Azure is owned by an American company. And that means that there might be compliance requirements about where the data can be and how the data center can be managed. And in different jurisdictions or different geographies, that is handled in different ways. The communication between on-premises and Azure needs to be secure and reliable. If an application is in a hybrid posture, what it cannot be is able to be intercepted if the traffic is passing from on-prem to Azure. So one of the other things that we're dealing with in this particular session is this question: which hybrid application technologies is appropriate for Tailwind Traders to use in a given set of circumstances? So when you walk away from this session, what you should be able to do is be able to identify which technology is appropriate for a given scenario. So Tailwind Traders has the following specific requirements. The first is, how can Tailwind Traders make applications that run on their internal network available to the internet without opening inbound ports on the perimeter firewall? The next question is, how can Tailwind Traders retire their current perimeter network and reverse proxy? That is, at the moment, they are publishing some applications that sit on their perimeter network out to the internet, and clients on the internet access those applications through the perimeter network firewall because those applications are sitting on the perimeter network. What Tailwind Traders really wants to do is shift those applications up so that those applications still sit on an internal network, but instead of having a perimeter network, the traffic comes in through Azure. Now, as part of their application modernization strategy, Tailwind Traders has moved some of the web tiers of their existing applications up to Azure. So instead of running on IIS, what these applications are doing are they're now running as web apps. But what Tailwind Traders wants to do is wants to be able to allow these web applications to use on-premises data sources such as SQL Server that's running on-prem. Eventually, they're intending to migrate some of these SQL Server databases into Azure, but at the moment they're very large and there is some issues around migrating those databases. So what they want to do is they want to have the front end sitting in Azure and they want to have the back end sitting on-prem. The next thing is they want to simplify the management of on-premises Kubernetes clusters. At the moment, they're running Kubernetes clusters using Windows containers, but there's a Linux infrastructure that basically serves as the command and control for those Kubernetes clusters. And this was very difficult for Tailwind traders to set up. And the person that set that up has left the company and is working for someone else. And basically, it's very hard to replace that expertise. So what Tailwind traders would like to do is come up with some way of simplifying the management of their on-premises Kubernetes clusters. Similarly, they want to simplify the management of their on-premises SQL and Postgres SQL instances. Again, that person that set all of that up has left the organization. They don't have the necessary experience with management of those databases. They've got people that know how to develop them, but they don't have the sort of IT operations experience with those particular products. So let's talk about hybrid cloud applications. What is a hybrid cloud application? Well, the easiest answer is a hybrid cloud application is an application that runs in the cloud. But practically, what a hybrid cloud application is an application that might have one tier in the cloud and another tier on premises, maybe the front end's in the cloud and the back end's on-prem. Now, moving to a hybrid cloud applications allows organizations to retire the perimeter network whilst keeping some of those applications in on-premises data centers. Now, the reason that they want to do that is if you think about one of the biggest security risks to an organization, it's the perimeter network. Simply because a lot of perimeter networks aren't particularly well configured and they require a lot of expertise to run and to monitor. If you can delegate that away to Azure, then you're probably saving your organization a lot of money in the long run. The other thing that you might want to do is you might want to allow application access to applications hosted on-prem on an internal network without requiring a virtual private network. One of the things that we learned in 2020, especially when people were working from home, was that it was often very challenging to allow them access to line of business applications that were running internally without setting up a complicated VPN or a remote desktop infrastructure. So one of the things that Tailwind traders would like to do as a part of their hybrid cloud posturing is allow access to those internal applications that might require, for example, Active Directory authentication, but allow access to those through Azure rather than setting up a VPN server on the perimeter network and allowing remote access through a VPN server. Instead, is there a way to publish those applications so that Azure can take care of all of the bits and pieces that allow access to that internal application? So in this session, we're going to look at Azure Relay. We're going to look at Azure App Service Hybrid Connections. We're going to look at Azure AD Application Proxy. We're going to look at Azure Arc-enabled Kubernetes and Azure Arc-enabled Data Services. So the first technology we're going to look at is Azure Relay. In previous iterations of this technology, this was sometimes called Service Bus Relay and also was related to BizTalk. Anyway, so what does Azure Relay do? It allows you to securely expose workloads that are running on your internal network to the public cloud. Now, a way a lot of these technologies work is that you essentially install an agent on-prem, that the agent on-prem reaches out to Azure and creates a secure connection to Azure. It doesn't go through your VPN. You can have a single agent on-prem, and that can actually reach out to a variety of different hosts that are on-prem. So from the agent to Azure, there is an encrypted connection, but it's not a traditional site-to-site VPN. Now, the other benefit of Azure Relay is it doesn't require you to open an inbound port on your perimeter network firewall. So the agent establishes an outbound connection rather than Azure establishing an inbound connection. It also allows you to publish applications to clients on the internet, whereas the endpoint will be in Azure, without configuring a VPN connection. Now, there's another technology we're going to talk about a little later in this session called Azure Active Directory Application Proxy. And you use Azure Relay when your application doesn't require Azure Active Directory authentication. If it does require Azure Active Directory authentication, fall over and use Azure AD Application Proxy. If you've just got an on-prem application that you want to publish to the internet, then use Azure Relay. So Azure Relay supports the following scenarios between on-premises services and applications running in Azure. It supports the traditional one-way request response and peer-to-peer communication. It supports event distribution to enable publish and subscribe scenarios, and it supports bidirectional and unbuffered socket communication across network boundaries. There's two types of Azure Relay. There's hybrid connections, and we will be coming back to hybrid connections when we look at app service hybrid connections, and they're very, very similar. They actually use the same technology, but here, when we're talking about Azure Relay, we're talking about the whole app being on premises. When we're talking about hybrid connections, we're talking only a tier of the app being on premises. So with hybrid connection, it uses open standard WebSockets, and it can be used across platforms. So with hybrid connections, you can have an on-prem app running Linux, you can have an on-prem app running Windows, and it doesn't matter. You can use a hybrid connection to publish that application so that it's available to clients on the internet through Azure Relay. There's also the Windows Communication Foundation relays. So WCF relays use Windows Communication Foundation to enable RPC or remote procedure calls. This is an existing option that customers use with their WCF program. It also supports WCF Relay, which is what this technology used to be called, as well as the .NET framework. Now let me talk you through the process that is illustrated in this diagram. Step 1 is that the listening client sends a listening request to the Azure Relay service. An Azure load balancer will route that request to one of the gateway nodes. In step 2, the Azure Relay service will create a relay in the gateway store. In step 3, the sending client sends a request to connect to the listening service. In step 4, the gateway that receives the request looks up for the relay in the gateway store. In step 5, the gateway forwards the connection request to the right gateway mentioned in the gateway store. In step 6, the gateway sends the request to the listening client for it to create a temporary channel to the gateway node that's closest to the sending client. In step 7, the listening client creates a temporary channel to the gateway that's closest to the sending client. Now that a connection is established between clients via the gateway, the clients can exchange messages with each other. In step 8, the gateway forwards any messages from the listening client to the sending client. And in step 9, the gateway forwards any messages from the sending client to the listening client. So what I'll do now is I'll show you a demo of how we actually set up Azure Relay. So here we are in the Azure console. I go to the search bar and I type Relay. I click on Relays. So we can see here that there's already a relay, and that is an app service relay. I'll talk about those a little later in this session. What I'm going to do is I'm going to create a new relay. So I select Add. This gives me the create namespace. So what I need to do is create a service bus namespace. I select my subscription and my resource group. In this case, I'm selecting the resource group, TWT Relay. Now, the service bus namespace must be unique in the world. So in this case, I've just called it TWT Relay servicebus.windows.net. Now, it will perform a check for me, and you'll see that little green check mark saying that it has validated that no one else is using that particular name. I specify my location. Here I'm specifying as East US. I click Review and Create, and it creates that Service Bus Relay namespace. The deployment's in progress, and the deployment succeeded. So I've created the Service Bus Relay namespace for this relay. Once I have done that, I can go to the resource, and what I can do is I can add a hybrid connection or a WCF relay. So if we select here on entities, we've got no hybrid connections for this relay at the moment and no WCF relays for this service bus connection at the moment. So I go back to hybrid connections and I add a new hybrid connection. All I need to do is provide it with a name and select whether or not it requires client authorization. I'll be able to connect to these later with my application. So we can see that we've got TWT web app, and there I can see the hybrid connection URL that is used when using that relay. I can select WCF relays. I can add a new WCF relay. Now, I can choose between NetTCP and HTTP in the relay type. And the one that you will choose will depend on how your WCF application is actually configured. I click Create. It creates that WCF relay. I can see the relay there, and by selecting the relay, I can see the properties of that relay. So here we see the namespace, the WCF relay URL, whether or not it requires client authentication, and the number of listeners that have so far been configured for it. So in that demonstration, I showed you how to configure Azure Relay with a WCF relay and a hybrid connection. So the next technology I wish to talk about in terms of hybrid cloud applications is the Azure App Service Hybrid Connection. So the idea of this one is, rather than, as we did in the first one, we created a full relay from Azure to your on-premises application. With an Azure App Service Hybrid Connection, what it allows you to do is allows you to connect an Azure web app, obviously running in Azure, to an application resource on any network that is able to forward outbound requests to Azure on port 443. So that could be a virtual machine running on premises. It could be a virtual machine running in someone else's cloud. Any resource that's able to send outbound requests. It can communicate with any resource provided it can function as a TCP endpoint. So clear and important here is that it's TCP rather than UDP. So the way that it works is you use a relay agent. You install a relay agent. That relay agent sits on your internal network and has direct line of sight to the data source, as long as that data source has a TCP endpoint. So it can be a SQL database, it can be a MySQL database, it can be a Postgres SQL database. Anything that functions as a TCP endpoint can be used with Azure App Service Hybrid Connection. Again, with this technology, it's not necessary to open an inbound port on your perimeter network firewall. And of course, it doesn't require that you have a VPN or an express route connection. So in this diagram, you can see that you've got a web app running in the cloud. You've got a system that's running on premises that's hosting the Relay Hybrid Connection. Now, if you want, you can have the Relay Hybrid Connection on the data source itself, which is what I'm going to show you in the demo, or you can have the data source on another system. For example, you can then configure Hybrid Connection Manager to connect through to the endpoint, such as a database. So what I'll do now is I'll show you a demo of setting up Azure App Service Hybrid Connection to configure a connection between a web app running in Azure and a database running on a VM on premises. So we start here on our VM. And what I'm doing on our VM, and this VM's running on premises, is I am verifying the IP address configuration. We can see it's 192.168.0.33. This is important for when we're setting up our endpoint. The thing I'm showing you here is that we've got a SQL database installed on this specific virtual machine, the one that's 192.168.0.33 as its IP address. Now, we're going to configure it so that a web app can go and talk to this virtual machine that's running on-prem. So to do that, what I do is I switch across to Microsoft Edge, and you can see here that I've opened up an app service. And this app service is called TWT HYB app, or Tailwind Traders Hybrid Application. So in the properties of this app service that we're looking at in the Azure portal, we scroll down and under settings, under TLS SSL settings, we can see that there's a networking section. And this section has VNet integration, hybrid connections, and Azure Front Door with Web Application Firewall and Azure Content Delivery Network. So what we do is we select hybrid connections, configure your hybrid connection endpoints. And on this page, we've got the option of downloading the Connection Manager software. So we select Download Connection Manager. We get the Connection Manager MSI installer file. We open that file. We get the start of the Hybrid Connection Manager setup wizard. So I accept the terms of the license agreement, and it goes and installs the Connection Manager software on this on-premises system. Now here, I click Finish. What I've chosen to do is I've chosen to put the Connection Manager software on the same server that's hosting the database. Now, I don't need to do that. I could do it on another server as long as it's got TCP connectivity to the server that hosts the database. So the next thing I'm going to do before I run the Hybrid Connection Manager is I'm going to add a hybrid connection. So I click Create New Hybrid Connection. I provide a name for the hybrid connection, in this case TWT SQL on-prem. I must provide an endpoint host. Now, the important thing about setting up the endpoint host is that the endpoint host address needs to be resolvable from the system that you've installed the Hybrid Connection Manager on. So it can be an IP address or a fully qualified domain name, but it needs to be an IP address or a fully qualified domain name that can be resolved from the computer or the host that has the Hybrid Connection Manager installed. So in this case, I just put the IP address 192.168.0.33. The next thing I do is I put the endpoint port. In this case, it's SQL, so I put 1433. The next option I've got is whether or not I want to create a brand new service bus namespace or select an existing service bus namespace. So we saw when we looked at the Azure Hybrid Connection that we actually created a service bus namespace for that one. This is a very similar technology, but instead of just doing a connection down from Azure for the whole app, in this case, we're connecting an app service to a particular TCP endpoint on-prem. So to make this as simple as possible, what I'm going to do is I'm going to create a new service bus namespace. I'm going to create it in the East US data center, and I'm going to provide it with the name TWT SQL on-prem. I select OK. It creates that hybrid connection. Once that connection is successfully created, my next step is to go back to the computer that I've installed the Hybrid Connection Manager on. So I select Hybrid Connection Manager UI, and I'm going to add a new hybrid connection. So I need to sign in to an account that's got permission to this resource. That's primeadmin and tailwindtraders.org. I click Next. I provide my password, and I sign in. It logs in, and it says select a subscription that you're associated with. I select a subscription. And what it does there is it performs a query on all of the hybrid connections that are configured for that subscription. So you just saw me create one where I specified that IP address, and you can see it there, 192.168.0.33:1433. It's important that you configure that addressing when you set it up in the cloud so that when you're on-prem and you're selecting that, it knows all of the plumbing and the routing that it needs to use to connect to that TCP data source. So I select that item, I select Save. It saves that item, and then what it'll do is it'll establish the connection. So we can see now that it's got a status of connected, and we can go in and view that connection details. We can see where it's connected to. We can also see the Azure IP address that it's going out and connecting to on the internet, as well as the Azure ports that it's using. So in Azure, it's 191.236.32.191, and it's using ports 80 and 443 on that host in Azure. It's also connecting to the internal IP address 192.168.0.33, port 1433. So it's created a connection between those two locations. So I close that, I minimize that, and I can see that it's listed as connected in the Azure console, and I can see the service bus namespace and the properties of that hybrid connection. So in that demonstration, you saw me configure a app service hybrid connection that configured a connection between an app service and an on-premises data source. So now that that is configured in the app service, I can configure the app running in the app service to access that connection just based on the name here, TWT SQL on-prem, because as far as the app in the app service is concerned, that connection exists and it doesn't care where that resource actually is. So that allows me to connect that app service app running in Azure with that on-prem database through that hybrid connection. So the next technology I want to talk about is Azure Active Directory Application Proxy. So the idea of this technology is it allows you to provide secure remote access to web applications running on an on-premises network through an external URL. That is, that clients on the internet use an external URL. They authenticate using their on-prem Active Directory credentials, which are replicated up through Azure AD Connect to Azure. This can be used as a replacement for reverse proxies or VPNs. There's a lot of organizations, as I mentioned earlier in the talk, who are publishing applications through VPN, where someone's got to authenticate to their VPN, and that gives them a connection into an internal application that's running on-prem. And you can configure this so that it can use remote access and single sign-on to web applications that use integrated Windows authentication, web applications that use header-based or forms-based authentication, applications hosted through remote desktop gateway, and on-premises SharePoint. So, in this particular diagram, let me talk you through how this works. In step 1, the user connects to the application through a publicly available endpoint. When they do that, they perform Azure Active Directory sign-on using their on-premises credentials. Step 2, a token's forwarded to the user's device after the sign-on completes. In step 3, the client device forwards that token to the application proxy service. That proxy service returns the user principal name and security principal name from the token. The application proxy then forwards the request to the application proxy connector. If single sign-on is enabled, the application proxy connector performs additional authentication. In step 5, the application proxy connector forwards the request to the on-prem application. And in step 6, the response is sent through the connector and the application proxy service to the user that's sitting in front of their browser on the internet. In this demonstration, I'm going to show you how you set that up in Azure. So important to understand, just before I start the rest of this demonstration, is that this environment already has on-premises Active Directory domain services configured to replicate to Azure AD through Azure AD Connect. That is necessary before you take this next step. Now, the other thing about setting this up, especially on Windows Server 2019, is that there's a number of steps that you must take before you configure your connector software. And these involve editing the registry. So I click the Start button and I go into the registry editor. I run it as administrator because I want to edit the registry. So here we need to create some keys and modify some existing keys. So the first key is HKey local machine, software, Microsoft Windows, current version, internet settings, WinHTTP. And here I'm just using a bit of PowerShell to actually create a HTTP to default enable key. And we set that set to 0. The next thing we need to do is we need to go in HKey local machine, system current control set, control security providers, S channel or secure channel protocols. And what we need to do is we need to actually create some keys and set some registry entries. So what I do first is I create a new key, and that key is called TLS 1.2. And a key is basically a folder in the registry, if you want to think of it that way. So within that TLS 1.2 folder, I create a D word, and the D word is disabled by default, and I leave that at the default setting of 0. I then create a new registry entry, another D word, and this one is enabled, and I set the enabled value to 1 to turn that on. I then create a new key under TLS 1.2, and this one is called server. So within server, I create the same registry items that I actually created under TLS 1.2. So the first one is disabled by default, and that's set to 0. The next registry item is enabled, and we set the value of that to 1. Then we navigate to the final area of the registry that we need to configure. And again, this is a little more into the weeds than it usually is when you're setting things up to work. So here we go into the .NET Framework registry. We go into the version 4.0.303.19. We create a new registry entry called SCH use strong crypto, and we set the value of that to 1. Once we have configured all of those registry entries, and we have to do it manually, even on Windows Server 2019, we need to restart the server. So we restart the server reboots, and those registry entries will take effect. Some registry entries take effect automatically, some it's better just to actually push through a reboot. So now that we've performed the reboot and we've signed back on, what we're going to do is we're going to open up Microsoft Edge. We're going to sign in as prime admin at tailwindtraders.org. We put in our password. We're in the Azure portal. We go to Azure Active Directory. We scroll down and we select Application Proxy. So Application Proxy does require Azure AD Premium. We've already got that configured. Next thing we do is we download the Connector Service software. That downloads the Connector Service software executable. I click on that. It starts the installation wizard. I accept the license terms. I click Install, and it runs the Application Proxy installer. That requires me to again sign in with an account that's got appropriate permissions to Azure Active Directory. It needs global administrator permissions to do this. I click Sign In. It then configures the connection between this particular system and Azure Active Directory. So if I do refresh, I can see here that I've got a connector established, and once I've got a connector established, I can configure a new application. So I give the application a name. This is the internal Active Directory Authentication app. This is the internal URL that is resolvable from the machine I just installed the connector on. It's just HTTPS internal app. We can see that it's given me an external URL, and we can configure some additional settings. So HTTP cookie only, whether it requires secure cookie, persistent cookie, translate URLs between the internal app and the external app that clients will be accessing this application to from the internet. So if we look at the properties of this application here, we can assign users and groups to that application. We can turn on single sign-on. We can provision user accounts. We can configure a custom policy, and we can configure whether or not that's self-service. If we go to properties here, we can see the homepage URL of that particular application. And the user accessible URL, the application ID, whether or not user assignment's required, and all of the other settings that you would configure for this application in the same way that you would configure an application that was running just in Azure. Okay, so the next technology I want to talk about is Azure Arc-enabled Kubernetes. So what Azure Arc-enabled Kubernetes does is, instead of installing a Linux head node to run your Windows Server containers, what it does is allows the management of Kubernetes running on-prem through the Azure portal. So it's a lot simpler because you're just running Kubernetes through Azure being your control node rather than doing it through basically hand-built Kubernetes. It allows you to connect Kubernetes clusters outside of Azure, and you can perform inventory, grouping, and tagging tasks. You can deploy applications and apply configurations to Kubernetes clusters using GitOps-based configuration management. You can use Azure Monitor for containers to review and monitor your hybrid Kubernetes clusters. And you can apply Azure Policy for Kubernetes policy to hybrid Kubernetes clusters. You can see in this diagram, we've got Azure on one side and we've got Azure Arc-enabled Kubernetes clusters. Now, the advantage of Azure Arc-enabled Kubernetes clusters is all of the plumbing for that is done for you automatically by Azure Arc, which means all you have to worry about is deploying the application, and all of the Kubernetes management itself is handled by Azure. The next topic I want to talk about is Azure Arc-enabled data services. So what this allows organizations to do is to run Azure database for Postgres SQL servers and SQL managed instances on-prem. So what that means is, instead of you being responsible for managing your Postgres SQL servers or SQL Server, you can do what you do in the cloud, which is you allow Azure to manage Postgres or Azure to manage SQL Server, and you just worry about running the database on it, so that it's running it on-prem in a virtual machine, except for you're not worrying about the care and feeding of that VM. That's being handled by Azure Arc. You can manage it through Azure Data Studio, Azure Portal, or the Azure CLI. And the advantage of this is it automates the patching and update processes for these on-premises database instances. As I said, you just worry about running the database. The database engine and the operating system that hosts the database engine is all updated and managed automatically by Azure Arc. It also, when you light this up, applies Database Advanced Threat Protection functionality in Azure Security Center for managed SQL instances on-prem, which means that you get all of the security configuration and all of the security monitoring functionality of Azure Security Center for when you would use those things in Azure for your on-prem instances. It also uses container and Kubernetes services to host the managed databases instance. This is the way that it does it. So it's not actually deploying a VM, it's deploying Postgres and SQL in containers, and the containers themselves are being managed by Azure Arc. Anyway, in this session, I talked about how you could use Azure Relay to make internal applications available to the internet without having to open inbound ports on your perimeter firewall. In this session, I showed you how you could use Azure AD Application Proxy to allow Tailwind traders to retire their reverse proxy for applications that required on-premises Active Directory authentication. In this session, I talked about how you could use Azure App Service Hybrid Connections to allow Azure Web Apps to use on-premises data source. In this session, I talked about how you could use Azure Arc-enabled Kubernetes to simplify management of on-premises Kubernetes clusters. And I talked about how you can use Azure Arc-enabled Data Service to simplify the management of on-premises SQL and Postgres SQL instances. On this page, you can see an additional set of resources that'll take you to docs.microsoft.com and actually allow you to see in much more detail how to use Azure Relay, Azure App Service Hybrid Connections, Azure AD Application Proxy, Azure Arc-enabled Kubernetes, and Azure Arc-enabled Data Services. Thank you very much for your attention. Okay, so in that session, we looked at hybrid cloud applications and we looked at hybrid cloud data. Now we're going to take a break for 10 minutes, and when we come back from the break, we're going to look at hybrid cloud security. Hope to see you in the session.
Welcome back from the break. This is our fifth and final module of our Microsoft Virtual Training Day implementing hybrid infrastructure. In this module called Hybrid Security, we will have a look on things like how we can take advantage of Azure management and security technology to have a look that our servers have the most recent updates installed and are compliant with our company policies. So let's have a look. In this session, we are going to talk about hybrid cloud security. And we're going to have a look how organizations can take advantage of cloud security from Azure for their on-premises or even multi-cloud systems. We are again going to use our demonstration company Tailwind Traders, which represents everyone and no one at the same time, to make some examples of how you can actually implement hybrid cloud security in your environment and take some advantage of what a company and an organization can actually do. So to get started, again, I want to quickly highlight a couple of the requirements Tailwind Traders has. And again, in this session, we're going to talk about and focusing on security. Now, Tailwind Traders, as mentioned before, is a company which goes in a hybrid environment, meaning that they are moving some of your workloads to Azure, but for other reasons, some of their workloads need to stay on-prem. So they, for example, have workloads which can't move to Azure because there's no network connectivity, or they have a bad latency to the next Azure region, as well as some data sovereignty challenges as well, where they can't store data outside of their premises or outside of their country. Now, however, Tailwind Traders wants to take advantage of the Azure cloud security because they saw how advanced their cloud security services in Azure are, and they want to use the same set of tools to all secure their on-premises workloads as well as their cloud workloads running in Azure and even at other cloud providers. So we're going to have a look on which hybrid security technologies Tailwind Traders should use for their environment. So in this session, we're going to have a couple of different scenarios Tailwind Traders will have a look at, and some of the challenges they're actually dealing with today. And we're going to have a look how they can solve these challenges using some of our Azure services. So the first one we are going to have a look at is how can Tailwind Traders ensure that all their servers in their hybrid environment have the most recent software updates installed. If you are a server admin, you know which is responsible for patching your systems, you know exactly what I'm talking about. It's very difficult to actually make sure that all the systems have the latest patches installed, that they're actually automatically patched, especially when they're running at multiple different locations. The next thing we're going to talk about is how they can manage their hybrid cloud environments and their servers and their systems to check that all their configurations are compliant with their company policy. We're also going to have a look at how they can actually see if important files on their hybrid cloud compute workloads have been altered. So we're going to check with for example, different security tooling to make sure that if there is a security threat, we can actually detect that. And then last but not least, we're actually going to we're going to have a look at how they can take advantage of the event logs of your Windows systems or also syslogs of your Linux systems in a log analytics workspace, and then actually scan the environment through these logs and have different information and take advantage of that. And then from there, even create alerts to see when there's something happening. So these are some of the scenarios we're going to have a look at. With that, we are looking at the following technologies. In this session, we're basically looking at Azure Update Management. We're going to have a look at Azure Arc Enabled Service, especially together with Azure Guest Configuration policies to actually manage the configuration of the operating systems and audit these machines to see if they are compliant with our company policies. We're going to have a look how we can take advantage of Azure Security Center, not just for our workloads running in Azure, but also our workloads running on premises or at other cloud providers. And then we're going to have a look at hybrid monitoring and how we can actually monitor our servers and then take advantage of the centralized log collection we have using Azure Log Analytics, and then basically run queries against these logs and actually find out and then even create alerts from there. So before we start with that, I quickly want to talk about cloud security in general. And again, that doesn't really just mean for the workloads you run in Azure. It means your hybrid cloud as well, right? And we see that as a shared responsibility. Microsoft is obviously committed to secure the foundation, meaning that we make sure that the physical assets like our data centers are protected, that no one can access them at any time, that the data is protected, that no one can steal data out of it, and so on. We also want to make sure that the same thing happens, that our data center operations are secure, to make sure that obviously the data centers are running on one hand, but also that no one can access your data. And the same thing is about the cloud infrastructure, talking from hardware as well as software, right? We want to make sure that the software again and the hardware again running in our data centers, but also the things with Azure Stack HCI, for example, or Windows Server, or Azure Stack Hub, or Azure Stack Edge, and all these devices, that they are also secured, and we actually want to make sure that they get the most security they can get. But there are some parts where the customer needs to take action, and that is where we see it as a joint responsibility, right? We don't just want to give the customers the tool in place and then just see whatever the customer does with it, because let's face it, we all have enough to do, and none of our companies probably has enough security people in the company itself, right? And so Microsoft, we internally spend billions on security and making sure that our assets are secure, but also our customer assets are secure. And so we want to take advantage of that, of our knowledge, and share that with our customers and provide our customers the built-in tools and controls to make their workloads and their deployments secure. So even though we make sure that the platform is secure, when it comes to virtual machines, servers, and virtual networks, you need to make sure that you actually secure them. When it comes to apps and workloads running in Azure, but also in your own data centers, you want to make sure that they are secured and that they're configured in the right way. And same thing with data. You also want to make sure that this is encrypted, right? And again, there's no difference from like running it in Azure or running it in your own data centers. If you're using Microsoft technology, for example, in Azure, we want to provide you with the right tool set to actually take security measurements, encryption, and so on to help you securing your workloads. And again, the same thing also applies obviously for hybrid workloads. We want to extend that. We don't just want to say, okay, we're going to help you with security as soon as it runs in Azure. We also want to help you obviously with security when it runs in your own data center or even at another cloud provider. Now, let's start with the first challenge we are seeing from Tailwind traders. One of the largest challenges is update management. So what Tailwind traders needs to do is they need to actually patch physical and virtual machines running on premises and in the cloud, in Azure, but also other cloud providers. And they're running Windows Server and Linux workloads. And again, they need to make sure that they have the latest patches installed. They want to have a possibility to get a compliance view to actually see which systems are not patched and which systems are patched, so they know, okay, where they need to work on. And then they also want to have a centralized dashboard, if you will, where they can actually start the update process and deploy these software updates to the specific machines. And that is exactly where Azure Update Management comes in. So Azure Update Management does a couple of different things. If it's configured, it actually goes out and checks the update compliance states of Windows Server and Linux machines running on-premise, at other cloud providers, or in Azure. It then can go out and even deploy and install software updates, again, running on Windows or on Linux, basically on any infrastructure. And that really helps to avoid that Tailwind traders need to have different products depending on the operating system or the location that server is running. So that is where Azure Update Management comes in. And if we have a look at the architecture here, here's a quick architecture diagram, how that can work. You can see here on the right, we have Azure, and then on the left we have on-premises or Azure VMs, really depending on where you run them. Now, what are you actually doing? We're taking Azure Automation and Log Analytics and have built this update management solution with these products. So we actually go out and install the Log Analytics agent, which then reports the update status to the Log Analytics workspace. The update management solution then goes through these logs and basically can find out, okay, which updates are installed on which specific system and which ones are missing. And then with the deployment part of the update, which I'm going to show you in a quick demo, you can actually go out and trigger the updates on these specific machines. And again, in different environments, again, we can use Azure, but in a hybrid environment, we have something called the hybrid runbook worker, which then actually will go through and trigger these updates. And you can even configure pre and post steps. So if you, for example, need to actually like run a script before you install an update and then run a script after the update is installed, you can do that as well. So with that, let's have a look at the Azure Update Management demo. Now here I'm back in Windows Admin Center, and then what I'm going to show you is I'm going to onboard my on-premises systems here running in my local domain, in my local data centers, in the Tailwind Traders data center. I'm also going to onboard one of the Azure machines, so you can actually see that we can then both see Azure VMs and non-Azure VMs side by side. Again, here I could also add machines from other cloud providers if I needed to. Again, it doesn't really matter where these machines are running. At the end, we can see them in a single pane of glass. So let's start and let's onboard one of these servers. Now I'm going to do that using Windows Admin Center. I'm going to the update solution or the update extension. There I can manage my updates locally. I can go and say, okay, install the latest updates. However, I want to have that centralized view. So I'm going to join that server to Azure Update Management. So I click on the server I want to join. I go to Updates. And here I can now click on Update to onboard the server to Update Management. I'm going to select the right subscription, the region for the Log Analytics workspace. I give the Log Analytics workspace a name. I give the Azure Automation account a name, and I create a new resource group or use an existing one. In my case, I have the hybrid RG, and then I'm going to click on setup. Now what this will do is it will go out and create, in my case, a new log analytics workspace. And then it will install the agent on that specific server and join that data to the log analytics workspace. It will also create the Azure Automation account. Now, in the meantime, let's go to our server running in Azure. We also can do that using update management. Again, do the same steps here to onboard that to update management. You could also join a server or a VM running in Azure directly within the Azure portal. You don't need to use Windows Admin Center in this case, but if you're using Windows Admin Center, you can do that as well. You can see here, I'm going to use the same log analytics workspace and Azure Automation account I'm using for the other machine as well. So basically then we get the single control plane. So this again will then download the agent and join it to the specific log analytics workspace. And if we go then to Azure, to our automation account and the update management solution, we will now see here our two machines here. One of them running in Azure, the other is non-Azure VM, and one of them is not compliant. So let's fix that and create a new update deployment. We provided a name. We can select the operating system because depending on which operating system you're patching, it's a little bit different. You can then select a group of machines. Now, a group can be different types. We can, for example, just select all the servers joined to a specific subscription. We can also filter on tags, for example, and so on, or locations and resource groups. We can also do that similar to, for example, non-Azure VMs, and we can all filter that. Or I quickly show you that we can also just select single VMs. In this case, I can just go and, for example, search, or I can just list my machines here. And then here you see the two machines, and I could just add them as well, like just separately as well. In the most production case, you will probably add a group based on, for example, tags. And then you can select which update classification should be installed. You can include and exclude updates if you need to. You can then schedule the specific update. So I can go that, and I can also create a recurring update if I want to. I can then configure pre and post scripts. I can configure the length of the maintenance window and the reboot options. So reboot if required sounds like a good idea. And then I create that scheduled update deployment. Now this will go out and then start that deployment for my machines. And you can see here, one of the machines is not compliant, but both of them have updates missing. So this is now a deployment. We can see that on the deployment schedules. We can see that, and after a while, after deployment has run, we can do a quick, for example, refresh. And now you will see that both servers or machines are now compliant because they have no updates left anymore. They're fully patched in this case, and we have basically all the updates installed. Now, again, this is great for a couple of scenarios. Makes it super easy. You can even schedule, and as I said, these updates for the future, so you can make them recurring updates. What I usually do, or what our customers very often do, is they do that based on tags. So you have, for example, if you have domain controllers or clusters you want to patch, you don't want to patch all nodes at the same time. So what we do is we create an update tag for upgrade group 1, where is domain controller 1, and then update group 1 gets patched on a Tuesday, and then domain controller 2 is in upgrade group 2, which will be patched on a Thursday, for example. So you can work with that. You can also do that dynamically, and really it just goes out and checks on the specific tags, but depending really on how you integrate update management. So this was the update management demo. Update management, as mentioned, does a couple of different things. It goes out, it basically assesses your systems. You can then deploy updates to it. It verifies the compliance of these systems and again assesses this, and you can again deploy updates to it. It works with Windows Server and Linux VMs. It can run in Azure, other cloud providers, or on premises. You can do custom approval criteria. You have that single pane of glass where you can see all your servers and the patch state of all your servers. And again, you can schedule these and do these update deployments, for example, weekly or monthly or whatever you prefer. So the next thing I want to talk about are different pain points here. What we can see here from Tailwind traders, right? And I just want to highlight a couple of them. Some of them, of their environments, they really want to have an overview, make sure that they have a compliance, right? They actually can see that their infrastructure is compliant, that their servers are compliant with different company policies. Also, their compliant experts are coming and say, hey, we want to have a list of all the servers from a specific department and want to see that they're compliant with that specific status. And we actually need tools to measure that. Now, you can imagine in Azure, for that, we have Azure policy and Azure guest configuration policy. But the question often came, how can we do that for systems which are running outside of Azure? And the answer is easy. We talked about that before. It is Azure and Azure Arc enabled servers. Now, I showed you before how that actually works, different things like how you can onboard servers. We showed you different management tools like Azure Monitor you can easily then use within Azure. Now for this scenario, I want to highlight you the governance and security features. And we're going to have a look at the Azure guest configuration policies we can assign to Azure VMs, but also to on-premises servers running Azure Arc, the Azure Arc agent. And then we can actually do a compliance check about our whole environment. So this is the architecture I showed you before. Again, on the left side, you see our on-premises servers. These could also run at other cloud providers. And we actually installed the Azure Arc server on these machines. And they are now part of Azure as an Azure resource in the Azure Resource Manager, and we can then onboard different Azure management services like Azure Monitor, Azure Update Management, or now what I'm going to show you now is Azure Policy. So let's have a quick demo for Azure Arc configuration management with Azure guest configuration policies. So here I'm back in the Azure portal, and you can see here the machine we recently onboarded to Azure Arc. And it again shows up as a Azure resource. And if we have a quick look at that machine, you can see here the status of the machine is connected. It's joined to a resource group, subscription. So it is now an Azure resource. So let's switch to Azure Policy. And Azure Policy lets me manage all these policies for my environment. And let's create a new assignment. So I'm going to assign a new policy. I'm going to select the scope. This can be a management group, subscription, resource group, or even a resource. So in our case, we're just going to select a resource group. And then I'm going to select the policy definition. And we have some built-in ones here, which you can leverage. And so we're looking for one, which basically checks if automatically update protection signatures are deployed. So we can select that, and then we can give that a description. Now, these are built, as I mentioned, built in, so you can just start using them. You can also build your own if you wanted to. So we have a GitHub repository where you actually can find examples how you build your own policies. So I'm assigned that policy, and this will take a while. We can now go to compliance view. It will actually check the compliance state of my systems within that resource group. So we will take the power of video editing and come back a little bit later in time. And you can see here now it says compliant. So if I go to this policy assignment now, I can see here that for my Microsoft anti-malware for Azure should be configured to automatically update protection signatures is working. And I can obviously then see all my compliant resources. I can see, if I have non-compliant resources, I can also list those, and I can actually figure out, okay, how many resources are actually not working. I can then go out and see why are they not configured the right way, and then actually take action on this. Now, Azure Policy is a great way. And again, with Azure Arc, we could now see the different servers running in Azure or also outside of Azure next to each other, and we get that single pane of glass where we can see the compliance view about that environment. So that was a quick demo about Azure Arc guest configuration policy. The next technology I want to talk about is Azure Security Center. Now, Azure Security Center really helps us with a couple of different things when it comes to security. It can actually go out and find threats and make us recommendation and alert us. So this is a great service, and you'll probably have seen if you configure your Azure workloads that you can enable that for your specific workloads and subscriptions to get all that information together. What a lot of people don't know is that you can also connect your on-premises, private cloud, and other public cloud provider workloads as well. So how we actually doing that is by using Windows and Linux agents, which then can go and get the Windows event log or syslogs or configurations from these specific servers and other services as well. We then do some normalization and we add some additional information to these logs with the agent, because then we can make some smarter decisions and give you some smarter recommendations as well. These will be then stored in a scalable log analytics platform, which we're going to see a little bit later, where you can then actually go out and you could already go and export these logs to Excel or Power BI and do your own analytics on it if you wanted to. However, with Azure Security Center, we add a little bit more to it. So what we do is we obviously can also add other Azure services like networking and PaaS services as well. And then we take advantage of our threat intelligence. So we spend a lot of money on protecting our own cloud services, our services like Xbox Live, Office 365, also Azure, obviously. And we take all that and much, much more information, and we do some security analytics in it. With that, we can then do threat detection. So we can see, for example, if one of your servers connects to an IP address, which we clearly know is part of the darknet or is an infected PC or server or whatever, we can actually tell you, hey, this system connects to an IP address which it definitely shouldn't connect. You want to take action on that and have a look, why is it doing that? We can then also give you recommendations to actually, before something happens, to make sure that your environment is configured in the right way. So this is all then done, and then we will present that in Azure Security Center, where you have a security dashboard which delivers you the insights into what is going on in your environment. It gives you security recommendations, again, to take actions on these specific tasks. And then you can even go out and do some further investigation with log search and so on. Or you can then go out and create security alerts. Like you can then, for example, just send notifications. You can trigger some REST APIs or build your own automation to actually do whatever you need to do. For example, send you a message in Teams or send a message in a Teams channel to a specific team so they can take action on it. So pretty cool stuff. And again, not just available obviously for Azure resources, but also for hybrid resources as well. And that is what we're going to show you in a quick demo. So let's do a quick demo on Azure Security Center. So here I'm back in Windows Admin Center. And what I'm going to show you here is how we can onboard a machine, which we haven't really used yet, and onboard that to Azure Security Center. So we can actually send these logs into a log analytics workspace. And then from there, we actually connect it to Azure Security Center, and Azure Security Center will then give us security recommendations and obviously also alerts if something would happen. So for that, I want to show you how that is done. So let's select server 2 here, connect to that server. And now we can simply go to, for example, Azure Security Center. That will help us easily to onboard that. So I can select my Azure subscription here. So I create a new Log Analytics workspace. Again, in your production environment, you probably use the same Log Analytics workspace you also use for monitoring and other things. But for demo-wise, we just create a new one. We also create a new resource group for this demo. And then we click on Setup. And this will now create this new Log Analytics workspace. This will create this specific information like the resource group, and then we'll download the agent and configure the agent on that machine. And you can see here, here it would show then the recommendation. It will take a while until actually these logs are analyzed. In the meantime, let's connect to another server and do the same thing as well. But in this case, we are just using an existing one. So you can see here we have the workspace already selected. So we're going to select that specific workspace. And let's go back and let's also add our server running in Azure. This one, again, is our Azure machine. So we can select that as well. Again, you can also directly onboard this from the Azure portal as well, if you want to. So here again, we just select the existing workspace. We click on Setup. And now this will set up Azure Security Center on that specific machine as well. Now let's jump to the Azure portal. Here we are in the Azure Security Center, where you get all the recommendations and the overview. Under inventory, we can now see all the systems we have joined. So you can see here a couple of virtual networks and virtual machines, but also my on-premises machines. So if I switch back to Windows Admin Center, as a server admin, I can now go into my server here with Windows Admin Center, go to the Azure Security Center, and I will get the recommendation directly for my system here. And I can see what I need to do. I can click on it and it will take me to the Azure portal where I can find even more information about that recommendation. So this was the Azure Security Center demo. Now, the next thing we want to have a look at is hybrid security monitoring for your environment, right? And there are a couple of scenarios where we can actually go, and we have a couple of different products here available which you can leverage in your environment. So how we attach hybrid workloads which are running outside of Azure is by using an agent, right? So we're going to deploy a agent on these hybrid operating system workloads, and depending on the operating system itself, we can then send the different security log data to, for example, Azure Log Analytics, and then also to Azure Sentinel. So what we can do here is we can actually go out and, for example, send Windows security events with a connector to Azure Security, to Azure Sentinel. We can also send for different connectors for identity to actually send on-premises Active Directory domain service telemetry to Azure Sentinel. We also have one for Microsoft Defender for endpoint to stream the alerts to Azure Sentinel. And then for Linux, we also have connectors for Linux operating systems that can forward syslogs and other data sources basically to Azure Sentinel. Azure Sentinel then is a service, is a cloud-based SIEM solution, which can go and analyze this telemetry to detect and hunt and then prevent and respond to threats against our hybrid operating systems. Again, Azure Sentinel is basically a hybrid service running in Azure where we can connect different sources. You also have, for example, connectors from different hardware, network gear, vendors, which can also send logs there. So it's a really one place to get all your security logs together, and then you can do some analysis and threat hunting there as well. So to have a quick look on how that could look like in a more architectural way, you can see here on the left side, we have resources living outside of Azure. These can be, again, if you look at it, on-premises systems. These can be running on your infrastructure, can be physical machines, or it can even be on like Azure Stack as well. And then we can also onboard workloads which are running at other cloud providers. And then they can be basically collected and then connected to Azure, to the Log Analytics workspace. And then you can take advantage of things I just showed you, like Azure Security Center or Azure Sentinel, which will give you that advanced security, these advanced security services. So I think it's quick time for a demo about hybrid security monitoring. And again, this is not just necessarily about security monitoring. It's like I want to show you a little bit how monitoring in general can work for your hybrid systems. So what I'm going to do here is we're back in the Windows Admin Center, and we are going to onboard a server to a Log Analytics workspace. And then we're going to use the keyword query language to basically do queries against these logs. And we're going to show you that you actually can get everything out of these logs from different systems, everything you actually added in the connector. And then you can go through and get all these logs out. Doesn't matter if it's security logs or performance logs or system events, whatnot. And then you can then do different things like create dashboards, or you could create security alerts, and much, much more. So let's get us started first. We move to the Azure portal and let's create a new Log Analytics workspace. We showed you that many, many times in Windows Admin Center, but for now, let's create a new Log Analytics workspace actually in Azure. Again, in production, you will probably use the same one. So we give that a new resource group. We give that Log Analytics workspace a name, and we select the region where the Log Analytics data is stored. Pricing wise, this is basically pay as you go. So the more logs you send into the Log Analytics workspace and the more you store, the more especially will that service will be costing. And so we create that deployment process, and this will create a new Log Analytics workspace. So let's switch back to our Windows Admin Center. And let's go to our file server 1 here. And we can actually now configure Azure Monitor. So for that, we click on Azure Monitor. We select the server here. And now we're going to select the subscription, and we're going to use an existing resource group. So with that, then we can also select an existing Log Analytics workspace. And then we hit Setup. And this will now go out and download the agent, connect that agent to the Log Analytics workspace, and send these logs, sending logs to the Log Analytics workspace. Now, when we're back in the Azure portal, let's go to that specific Azure Log Analytics workspace. And here we can do some advanced settings. So we can obviously here configure like more data sources. You can see that we can onboard more data, but let's for the connected machines, let's add a couple of logs we actually want to have. So first of all, I want to see the system log. So let's add that. And then we also want to have, for example, the application log. So let's add that as well. And then let's save this quickly. And now the agent will send us even more logs, right? And then we can do the same thing for performance counters. You can see here I have a couple of them already as default, but I can actually go here and then have a look at the different other performance counters. So you can actually go through like all the performance counters on these different systems. So whenever you need some performance data, you can actually find that here in that specific collection, and you can add that as well. Again, there's more to add, like syslogs and Linux performance counters and so on. You can even do custom fields if you wanted to as well. So now let's switch to logs, and this is actually the log editor, if you will, where I can actually create queries with the keyword query language. Some of you maybe remember it as Custo. So with performance here, with this query, I get the performance information in my Log Analytics workspace. So you can see here, this is all the different performance logs sent to that specific workspace. with all that information here. So you can see here, if I drill in a little bit more, I get even more information about what this information is. I can then also do other things. I can, for example, do some more queries here. So a very simple one here is obviously with events. So I can list all the events in my Log Analytics workspace. And again, this provides me now all the events of all the servers joined to that Log Analytics workspace, right? I can then do obviously some more advanced queries, so I can summarize them by count. So I can actually go out and summarize them by source, for example. So I can see here how many events do I have depending on the different event logs. And then I can also obviously drill into these and find some more information. Okay, so what is it actually depending on the different results I get here. I can also do, like, if I go back and do just events again, I can then see and drill into the different events here, for example. So I have a like DNS event and so on, and I can then find all the information for that specific event entry, not just necessarily like I showed you before from the performance part, but also from the event itself. Now, from here, obviously, this is great if I just want to search for something really specific, but I can build some really nice queries, like really advanced queries, where I can really find just the information I want. I can use that for reports. I could also like just export this data. I can create new alert rules. Now from here, I could say, okay, whenever a specific event, for example, happens, or I build a query which goes just for a specific event. Let's say a specific user logs in to a machine. I could actually go out and build that query and then save that query and create a new alert rule. So as soon as a new entry is created, it will then actually create an alert, which then means it could be just send an email, a notification. It could go out and kick off a runbook. It could go out and send a message to Teams, for example, or whatever your automation basically is, and you can get notified about this. And again, same thing happens. So like if, for example, same thing on performance data, if, for example, you're running out of disk space or other stuff as well, you can build these alertings as well. Again, not just for security, but also for performance data or other events, you can create that. Now, you can also go out and, for example, build some nice charts. So if you just don't want to have this log information, you can go out and build a chart, which then actually shows you all the performance informations from your specific set of services, VMs, performance data, storage data, for example,